It's no secret that the James Webb Space Telescope has been a resounding success, delivering so far even better images, science, and even new mysteries than was expected. The long wait for that telescope was worth it. And while not a comprehensive list, here are 10 interesting observations JWST has performed so far and what they might mean. Number 10. The free-floating brown dwarf. On December 13, 2023, it was announced that the smallest free-floating brown dwarf has been discovered by the telescope and may call into question some models of star formation. Located in the cluster IC 348 at a distance of about 1,000 light-years, in a star-forming region in the constellation Perseus, this particular brown dwarf is somewhat puzzling in that this brown dwarf is very likely very young, at just 5 million years old. The study actually found 3 brown dwarfs, ranging from 3 to 8 times the mass of Jupiter. At such a young age, the brown dwarfs are hot and bright in the infrared, Webb's specialty. This particular one, the smallest, however, has only about 3 to 4 times the mass of Jupiter. This is very small for that, and the group actually creates a question because they fall within the size range of very large planets. So are they freely formed brown dwarfs, or are they ejected giant exoplanets from a star system? This is in current debate because it can't be ruled out, but it seems unlikely due to giant planets being rare for ejection, and the cluster's really young age hasn't left much time for that. So it may create more questions about star formation itself. Mysteriously, however, the observations also revealed a spectral signature of some kind of hydrocarbon, which remains unidentified within the atmospheres of 2 of these brown dwarfs. Number 9. The ringed asteroid. Chiricahua is a Centaur asteroid, a class that sits in unusually unstable orbits between Jupiter and Neptune. This particular one orbits outside Saturn's orbit, and is fairly small at 250 kilometers. This asteroid sports a rather interesting mystery. It has rings when only planets should have them. The rings were discovered in 2013 through the occultation method, meaning that the asteroid passes in front of a star, and that allows you to do precise measurements of an object's position and size. Here, however, there was a double blink after the occultation had finished, indicating a pair of rings about 400 kilometers from the asteroid's core. In October 2022, there was an opportunity to make the very first measurement of an occultation with Webb, with the target being Chiricahua, and sure enough, the rings appeared again. The JWST measurements should yield data on how thick the rings are, their color and particle size, and may even discover additional rings, but most importantly will help astronomers try to determine just why a body this small has a ring system. And it may be that Chiricahua was hit by an icy object at some point, and the rings are a remnant of that collision. Number 8. The silicate clouds of VHS 1256b. One of the areas where JWST was expected to greatly expand our knowledge is in the arena of exoplanet atmospheres and what they contain. A fine example of this is the exoplanet VHS 1256b. This planet orbits a double star system about 40 light-years away, but it does it very distantly, to the point that its year is equivalent to 10,000 Earth years. This actually made it a good target for Webb because at that distance, its signal doesn't get diluted by the direct light of the parent stars, allowing for a clean spectrum. It's a young, hot planet, only about 150 million years old, and as such has a somewhat strange atmospheric makeup that's in disequilibrium. Detected were water vapor, methane, carbon monoxide, and carbon dioxide. This holds the record for the most molecules ever detected on an extrasolar planet thus far. But there was another, Silicon. This planet sports silicate clouds, basically dust, on sizes ranging from the size of a particle of smoke all the way up to hot, small grains of sand. The disequilibrium suggests heavy atmospheric mixing, so this is a somewhat tumultuous world. This entry is proof of concept of what Webb can do with exoplanet atmospheres. Number 7. The temperature of TRAPPIST-1b. One of the more enticing discoveries of the last decade in exoplanet science was the discovery of the TRAPPIST-1 system, which has multiple planets, several of which are in the habitable zone of the star. These were among the prime candidates for JWST to look at, to try to determine exactly what these worlds are like. The first on the list was the closest planet to the star in this system, TRAPPIST-1b, which is not in the habitable zone. Rather, it's closer to the star and not a good candidate for life. As was expected, the observation showed TRAPPIST-1b to have no atmosphere at all, and is a very hot 230 degrees Celsius. This was actually the first time an exoplanet in similar circumstances to our own inner solar system has been analyzed, and now the task will be looking at the other planets in the system to try to get a profile of them. But that gets harder the further you get from the star. No guarantees, but we may soon know a lot more about this intriguing star system. Number 6. The Fomalhaut Asteroid Belt. The star Fomalhaut is known to have a very dusty environment since it's still relatively young, and it's close at just 25 light-years. Before JWST, the complexities of this belt of dust was not known, but it was thought that we might, in part, have been seeing an extrasolar asteroid belt not unlike our own. Dust glows in the infrared as it absorbs light from its star, and it radiates it in heat, which is what JWST as an infrared telescope is primarily designed to study. This will be important for entry number 1. As it turns out, however, the belts around Fomalhaut are very different and far more complex than those of our star system. As it turns out, Fomalhaut has 3 nested asteroid belts, extending out to about 23 billion kilometers from the star. That's very distant in comparison to the solar system. The belts are debris from the collision of larger accreting bodies, not unlike our own asteroids and comets. The outermost belt, which is enormous, had been photographed previously, but not the 2 inner belts. What's responsible for forming or shepherding material in the disk into belts is quite simple. It's young, unseen planets. This happens here. Jupiter is still corralling our own asteroid belt, and Neptune does similar for the interior edge of the Kuiper belt. And there are mysteries there because something may be shepherding its outer edge as well. In other words, an undiscovered planet in the solar system. There's also a further feature with Fomalhaut. There's an unusual dust cloud in the outer ring that might be evidence of a planetary collision at some point in the past, which is actually the second such detection. Hubble saw something similar in 2014 with Fomalhaut that actually seems to have dissipated. Number 5. The Giant Enceladus Plume. Enceladus plumes have been known for years. What happens is that the subsurface liquid water ocean beneath its ice can escape through cracks and spray into space from the equivalent of geysers here on Earth. They're known as tiger stripes. This is very lucky for us, in that it's much easier to analyze a plume in space and search for signs of life than it is to drill into an ice shell moon and see what's there effectively with a submarine. But until JWST, it wasn't clear to what extent these plumes could eject water vapor. As it turns out, it's at least 6,000 miles, according to measurements by Webb, which also revealed clues on just how Enceladus contributes to Saturn's ring system. It was known that Enceladus's plumes spread material deep into space, but it wasn't known to what extent the actual plumes extended before dissipating. And it also revealed how much water Enceladus is losing, which is about 79 gallons per second. Number 4. Organics in deep space. Organic chemistry is the basis of life on Earth. The vast chemistry of carbon is why we're here. It is, as far as we know, the only really good path towards life in the universe, though in fairness, there are questions about silicon. Naturally, whenever we look to the heavens for evidence of the potentials for life, we tend to look for carbon. But that long ago proved to be common. The stuff of life pervades the Milky Way, and the reason for carbon being so common are well understood. Yet verification for other galaxies is needed. And JWST has found a major benchmark in that search. Observations with the telescope have shown a very distant galaxy, about 12 billion light-years away, shows the chemistry of carbon. Carbon was around when the universe was a mere 1.5 billion years old. This discovery is interesting. It was actually the signature of an Einstein ring, a very distant galaxy gravitationally lensed by a foreground galaxy that itself was 3 billion light-years away. The carbon compounds seen were very similar to soot or ash, and the presence of these types of molecules in this case is a bit puzzling, and hint that our ideas of organic molecules and star formation may be too simplistic. But that's not the only discovery. In an area within the Milky Way known as the Orion Bar of the Orion Nebula, Webb was also able to see how stellar radiation erodes the bar over time, leading to the creation of carbon-based molecules and the chemistry of protoplanetary disks. Number 3. Carbon at Europa. Europa is alluring. We know it has a subsurface ocean, a vast one, at temperatures where life as we know it is comfortable. But that's not enough. You also need the materials that make up life. The most basic of these is carbon. This has been an open question regarding Europa. There was no evidence for the existence of carbon in the ocean itself. Carbon is a common element. There's an entire class of meteorite that's defined by carbon, and those fall everywhere in the solar system. So it's not surprising to have found it. But recent JWST observations have proven that there is carbon at Europa. The measurement was from an area of Europa's surface known as Terra Regio, and comes in the form of carbon dioxide deposits. Moreover, they were able to determine that the CO2 is very likely to have originated in the ocean below, rather than having been delivered by meteorites. And it's recent. Carbon dioxide is not stable on the surface of Europa over long periods. Oddly, however, previous evidence for plumes of water vapor escaping cracks on the surface of Europa, similarly to Enceladus, were not confirmed by the Webb observations, suggesting that plume activity may be intermittent at Europa. But we won't have to wait long for more information. 2 missions are set to explore Europa in depth, one being the Jupiter Icy Moons Explorer, which is already launched and set to arrive in the Jovian system in 2031, and the Europa Clipper mission is set to launch on a Falcon Heavy in late 2024 and arrive in 2030. Number 2. The atmospheres of WASP worlds. The wide-angle search for planets, or WASP, is an effort in exoplanet detection that has discovered well over 100 exoplanets. Once discovered, these exoplanets, if they are suitable, can become prime targets of Webb. The first of 3 examples would be the hot Jupiter, WASP-17b, located about 1,300 light-years away. This giant planet orbits its star very closely, and oddly in a retrograde orbit. This planet was found by Webb to have silicates in its atmosphere in the form of quartz nanocrystals. Interestingly, this planet is so hot that it's possible for nanocrystals to form directly from its constituent elements from gas, bypassing a liquid stage. The second is WASP-107b. This exoplanet has a mass comparable to Neptune, but a diameter approaching Jupiter. In short, it's puffy. This actually eases the challenges of peering deep into this exoplanet even more so than for solar system gas giants. Water vapor, sulfur dioxide, and more silicate clouds were found, but no methane. This provides a unique study of how heat works in traps on this exoplanet. In contrast is the third, WASP-80b, where methane was definitely found. This one is a warm Jupiter with a size and mass comparable to Jupiter itself. At 163 light-years away, this exoplanet shows a different temperature profile than our gas giants, and also sports detectable methane. This will probably be a repeated object for Webb to observe, due to the unique circumstances in that it may allow us the biggest bang for the buck in studying a gas giant atmosphere outside the solar system. Number 1. KIC 8462852. One of the most enigmatic discoveries in recent years was KIC 8462852, or Tabby's star. The behavior of this star has defied explanation to the point that the activities of an alien civilization are still on the table, though not as strongly as when the story first broke. The star's periodic mysterious dimming continues and still defies explanation. Whatever is blocking the light from the star is consistent with submicron dust, but it does not appear to be in a periodic orbit of the star. One enigma, however, is that an observation in infrared showed that whatever the material is, it must be cold because it was not detectable in infrared, leading to hypotheses about cold comets breaking up, but that would require an implausibly large number of comets in the system to account for it. One of the more common questions I get in the comments section here in at Event Horizon is, will JWST turn its eye on Tabby's star and take an observation? The answer is yes, and it's already happened. Last summer, between June and August, JWST took a series of 3 spaced-out images of the star in infrared, at much higher resolution than the previous measurement. The scientists involved have not yet released their findings, but it's possible that it might settle the question and pick up the missing infrared emissions. What will be interesting, however, is if it comes up null again. Given the curveballs the star has given us at every turn, it wouldn't surprise me if the mystery deepens with the Webb observations. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently looking forward to a new year of JWST observations. Imagine what we'll see. but also first light at the Vera Rubin Observatory, which is set to be a mystery factory as it picks up everything from asteroids, potential undiscovered outer solar system planets, and even interstellar objects cooking through. It's going to be good, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live. The march of scientific discovery and technological development relentlessly continues on, so here are 10 interesting scientific discoveries for November 2023. Number 10. The biggest problem with AI might be its energy use. The question of artificial intelligence and the dangers and pitfalls that lie within the subject have been prominent as of late as the development of AI marches forward. These range from how it's getting easier to cheat on tests and write papers to the question of when is Skynet going to appear, and obsolete humans and all that goes along with that. But one area that hasn't really been widely discussed is that AI is proving really energy expensive, and that may end up being the single defining factor in its future development. Case in point, search engines. If Google switched its entire search engine infrastructure to AI, it would use something on the order of 29.3 terawatt hours per year in electricity. This is comparable to the current usage of Ireland. This would also double that company's electric bill, which is a cost, and converting everything would cost over $100 billion and require far more computer chips, which tend to be limited in supply anyway. That said, chip manufacturing capacity is increasing, and no doubt, so will the prevalence of AI. The usage really is in training large models in AI, which is energy intensive. And there's always room for better efficiency to be developed. And also there has been headway in making smaller AI models work, as well as larger ones. But the fact remains that the energy use question will shape AI development, and it's barely being discussed at this point. Number 9. Gas waves on giant stars. We tend to think of waves as something to do with liquid. After all, the moon causes Earth's tides and contributes to the creation of its waves. But this can actually happen on a much larger scale, with something a bit different from a planet, the surface of a star. This phenomenon happens when you get a very close binary star system under the right conditions. In this system, known as MACHO 80.7443.1718, a smaller companion star is orbiting at times, close enough to disturb gigantic waves on the surface of its supergiant companion. These waves can actually get so large that they can match about 1/5 the size of the star itself and distort the larger star into an oval shape, and it's violent. The larger star is losing mass due to the spray of these giant waves throwing material into space, and the stars are spiraling closer, so this wave phase is only temporary. Whether they will eventually merge is unknown, but this particular system illustrates that binary star systems are very situational and can sometimes produce strange effects on their constituent stars, such as these giant waves. Number 8. A new gigantic crater in the solar system. The Kuiper Belt is not a place where you'd expect to find a huge amount of craters. Collisions can, of course, happen that far out, but the further out you go, the more diffuse everything gets. And while there's a lot of material out there, the chances of collision are less, though it has to be said that it's far from impossible, with some objects appearing to be barbell-shaped due to two objects touching and coalescing together, as in 486-958 Arrokoth, formerly known as Ultima Thule, that NASA's New Horizon probe explored. In this case, however, a very large crater appears to have been discovered on a Kuiper Belt object. Known as 2002 MS4, this object is an 800-kilometer Kuiper Belt object beyond the orbit of Neptune. Normally, this would not be an object we could directly image its surface in detail. It's very distant and very small. But in this case, researchers were able to capture the object as it passed in front of a distant star, an occultation. The light came back somewhat weird, in that part of the object was not round, which is expected for an object of its size. Rather, the northeast corner of the object appears to have an enormous depression in it, consistent with a 320-kilometer crater covering a very large area of this minor planet. In fact, it would be the largest surface feature ever detected on the surface of an object this size, and it ranks up there with the major planets. The rim of this crater appears to be taller than 25 kilometers, which may beat out Mars's Olympus Mons in height, the tallest volcano in the solar system. But this is also not a very direct way of having discovered a crater. Rather, it's possible, though actually more remote than a big crater, is that the object has a moon that's altering the image. Though if it is a moon, then the James Webb Space Telescope should be able to settle that issue, if not image the crater itself directly. Number 7. Exotic lab-grown mammoth meat and beyond. Lab-grown meat cultured from individual cells has been in development for some time, and indeed has come to fruition to a degree. There is lab cell-grown chicken that recently cleared regulatory hurdles and is now being served in a restaurant in California. This holds much promise, but won't be for everyone, at least not initially, in that the main idea is to get away from killing animals directly, but holds the promise of great improvements on meats like beef, where no natural means of production will produce marbling and other desirable traits, such as tenderness, like a lab-grown engineered product will. But there will always be those who don't go that route. But to put a new spin on this, lab-grown products may actually take a turn into new territory, or perhaps old territory, in two distinct ways. The first are meats not normally encountered that people will never try unless cultured, including things like zebras or lions. But what else can be thought about are DNA reconstructions of what mammoth meat might have tasted like to our ancestors, or for that matter, with enough reconstruction, you might even get close to what the dinosaurs tasted like. Even stranger perhaps is the idea of creating meats that correspond to no creature, essentially unicorn meat, that could be tailored genetically to produce flavors unlike anything else, for better or worse. There may come a time in the far future where all meat is cultured, and is fully of our own invention. Number 6. Blue Walker 3. The issue of an increasing number of satellites occupying a low Earth orbit is getting worse. While these new constellations of satellite promise great benefits to human civilization, such as internet and communications availability anywhere on the globe where humans exist, it comes with the cost of things like increasingly noisy astronomy. Visually, this is sometimes evident. Starlink, for example, can be somewhat stunning to see after a recent deployment. And the International Space Station passes very brightly overhead regularly and has done so for many years. But as our satellite presence in low Earth orbit continues to grow, we're gaining more really bright satellites, one of which is known as Blue Walker 3. This satellite is a prototype for a space-based mobile phone network. The problem is that the satellite presents 64 square meters of reflective surface area, making it brighter than most stars when visible. An increasing number of this sort of satellite will present a challenge to astronomy, specifically in all-sky survey telescopes like the coming Vera Rubin Observatory. Really bright objects like this can potentially even damage instrumentation, so the telescopes are likely to have to map out how satellites are moving and basically avoid them when they pass over, institute algorithms to clean the data if one passes by, or outright turn the telescope off while one passes overhead. This is going to add time to observation schedules in any case, and telescope time is always limited, especially with sensitive or large instruments. One thing that can be done, however, is that the companies running these satellite constellations can institute anti-reflective coatings or orient their satellites during sensitive observations to not reflect as much sunlight. In addition to this is something less talked about, that of radio astronomy. Downlinks from communication satellites on this level are going to be really powerful. So while a glinting satellite in visual light is comparable to a bright star, in radio astronomy the same satellite can outshine the sun. The answer as to how to mitigate this and find a balance will be something of increasing importance as we build our satellite constellations from here on out, and this will make for a very much more active night sky to viewers on the ground. Number 5. Prehistoric animal tracks accurately depicted by humans. Rock engravings in Namibia dating from about 5,000 years ago have been shown to be more accurate than had been previously thought. The engravings exhibit a myriad of human and animal footprints deliberately carved into rock. The purpose of these carvings is unclear. We know from recent findings in cave paintings in Europe that the paintings appear to have had a practical function, in that they may show in a series of dots and dashes and symbols when the animals of the area bred and gave birth, giving a kind of guide to hunting for anyone that happened to be in the area and be able to read the paintings. It's possible that this might be what's going on with these carvings, but it's impossible to say, other than whoever made them did so with great care to ensure that they were accurate. For the animal tracks, professional trackers were able to identify over 40 species, ranging from rhinos to birds, and even aardvarks, to detail so accurately that the exact species was identifiable, some of which are no longer living in the area, suggesting a different climate at the time. For the human footprints, sex was able to be identified. Why such accurate representations were important enough to painstakingly carve them remains unknown, and may be lost to the mists of time forever. Number 4. The dwarf mooing crocodile. One great challenge to conservationists tracking animal populations is that tracking some of them has proven extremely difficult. One really difficult one has been the African dwarf crocodile, which grows to about 1.5 meters, which is small for a crocodile. They wander all over their habitat in West Africa, from streams to forest, and are difficult to count, and are actually among the most obscure crocodiles on Earth because of it. We know very little about this species. Except we may have a way to track them now, mainly because they make a host of different sounds and vocalizations. These can be low-frequency hums, gusts, rumbles, and even one vocalization that basically sounds identical to a cow mooing. This spectrum of vocalizations these crocs make would be key in tracking and identifying them. Indeed, there was a case where 201 mystery sounds were recorded by elephant specialists in Gabon, and no one knew what they were until this study. It was these small crocodiles. So learning more about the species with microphones seems to be the way to go. Number 3. A Venusian case of mistaken identity. Venus is a planet of mysteries. Indeed, it presents some of the greatest unsolved mysteries of the solar system, to the point that it may have microbial life in its upper atmosphere, supported by a number of completely different hints from unexplained phenomena that happen in that planet's atmosphere. It's every bit as mysterious as Mars or Europa in this regard. Unrelated to that, however, is the mystery of strange flashes of light that are observed in Venus's atmosphere. Much has been made of lightning at Venus, especially in regards to the mysterious presence of phosphine gas in the planet's atmosphere. So much so that a prominent debunker on YouTube attributed the gas to lightning, even though that method of phosphine generation was disproven in the lab 25 years before. Always check the literature. But the actual inference of lightning at Venus itself was never proven either. We don't know that Venus has lightning. Rather, probes would pick up radio static very similar to what lightning produces on Earth, and random lights in the atmosphere. That may well make a case for lightning, and it very well could be there, but the problem was that the two did not correlate, and we're still not certain that Venus's atmosphere actually has the potential to produce lightning at all. That the flashes did not correlate with the static remained a major question. A new study, however, suggests that it may all have been meteors. Venus is nearly the same size as Earth, but experiences less meteor falls in its area of the solar system. But what it does see is different from Earth, in that they are moving at significantly higher apparent velocity on average when they enter, largely because Venus is moving faster than Earth, and as a result, they may be more energetic than meteors on Earth, mimicking lightning. This is important because future probes to Venus's atmosphere are going to need to know if there's lightning there or not. If it's not there, then that might make things significantly easier to prepare for. Still, the lack of correlation between the flashes and the interference is still not understood. Number 2. Plastic may not be problematic forever. Plastic is a problem on many levels. It gets discarded everywhere, and it imperfectly recycles, and lasts a long time and can fracture down into microplastics. Part of the reason for this is that it's difficult to make plastic economical to recycle. It's not like glass or metals, which recycle indefinitely. It can't indefinitely be made into new bottles, and the products made from used plastic are limited. The thing is, plastic contains some very interesting materials, and there may be a way to make them into something extremely valuable to reuse: fuel and graphene. This is a weird one. Seeking to find low-cost and more environmentally friendly ways to produce hydrogen led researchers to looking at heating household plastics. This works, and that provides one important resource that could come from our future reuse of plastic, potentially even old plastic recovered from the environment. But here's the kicker: the byproduct is graphene. Graphene is an extremely valuable and extremely useful cutting-edge nanomaterial that promises a great many things, including eventually contemplating things like space elevators. This process seems to be profitable from the start because even if the graphene were sold at a small fraction of its current market price, less than 5% of it, the hydrogen released becomes free, which also has significant market value. There is money to be made here in two different ways. Of course, that's in the lab. Actually doing it industrially is another matter. But there's a huge amount of room for profit in this one, and if it continues on this path, even old plastic may be useful. And once you lock the carbon up in the graphene, it's not likely to end up in the atmosphere. And the hotter the reaction, the less leftover byproduct there is. Number 1. Antimatter is not anti-gravity. One of the odd questions that floated around for many years was whether antimatter would actually fall upwards instead of downwards in a gravitational field. Part of the problem is that antimatter annihilates when it comes into contact with normal matter, so it tends to go away before a measurement of its behavior in a gravitational field could be measured. That was until recently, when an experiment was devised to catch a measurement, and it shows that antimatter does indeed fall in a gravitational field and is not anti-gravity. It was probably never the case that antimatter could have been anti-gravity. There just wasn't a good reason it would be. It's just a flipping of charges. But it wasn't certain, and you really have to test things before making pronouncements. So that was done with atoms of antihydrogen. But it may open up new mysteries in that what's not yet clear is whether it falls at exactly the same rate as normal matter. And the experiment was not precise enough to tell, but future experiments, should they show a discrepancy, might lead us into the territory of new physics. We shall see. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently pointing out on the behalf of the mooing crocodiles that they are still crocodiles. We don't know how old that particular species is, but the natural precursor of the cow, the aurochs, if it mooed, only evolved about 2 million years ago. Compare that to the 95 million year history of the crocodiles, which haven't changed much since the age of the dinosaurs. In other words, we should probably say a cow moos like a crocodile, instead of a crocodile moos like a cow. Just saying, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live. The march of scientific discoveries has moved on to April, so here are 10 interesting recent scientific discoveries for April 2024. Number 10. The X-59 aircraft. When examining the history of commercial flight, in some ways it appears that it stagnated or even took a step backwards with the retirement of the Concorde. Supersonic transatlantic flight then left the stage as far as moving passengers around. One of the problems of Concorde, however, was it couldn't really operate at supersonic speeds over land because of damaging sonic booms, and it also created very high engine noise in its own right, which limited it. As a result, sonic booms are illegal over populated areas. But this may change in that NASA recently unveiled their new X-59 supersonic aircraft, which is designed to minimize sonic booms and open the way for eventual legalization of supersonic commercial flight over land. Technology and aeronautics have come a long way since the design of Concorde, so it may well be that the X-59 is the first step to a new generation of supersonic commercial aircraft. Number 9. The Billion Crater Meteorite. You normally would not expect a single meteorite to produce multiple craters, but that actually isn't the case. Whenever there is a large asteroid impact on a body, enormous amounts of material is ejected, and that then falls back to the planet or moon's surface, creating secondary craters that can occur in clusters and chains, but also randomly around the original impact crater. Earth tends to weather these kinds of craters away fairly quickly, but numerous examples of this are known on the Moon and also Mars. And in the case of Mars, however, an extreme example of this effect has recently been discovered. Associated with the crater Corinto, which formed in an impact about 2.3 million years ago, researchers were able to estimate the number of secondary craters present in the area, and it actually came out as over 1 billion, possibly several, spread over a 1.4 million square kilometer area. The mystery here, however, is in just how a relatively small crater like Corinto could eject enough material to create that many secondary craters, but it did. Number 8. The Dark Primordial Galaxy. We think of the modern universe as having more or less all of the galaxies it's likely to ever have, and the days of primordial clouds that could collapse to become galaxies are over. But it's always been hypothesized that this may not actually be true, and that some dark primordial galaxies might still persist. Radio observations done at the Green Bank Radio Telescope, however, may have stumbled across the first known example. Known as J0613+52, it appears to be an enormous galaxy-sized cloud of hydrogen that initial optical observations determined is emitting no visible light, just the natural radio emissions of cold hydrogen clouds. This may mean that the galaxy never had the conditions needed to kick off star formation, such as enough gravity to begin to pull things together, or another trigger, such as a passing galaxy, to do it. This one, however, is isolated and may never have had any of that happen, leaving it as a primordial hydrogen cloud about 270 million light-years distant. Interestingly, while it's still just a candidate, astronomers hope to train optical telescopes in the cloud for many hours specifically in hopes of seeing nothing. If no light is seen at all, then it will be the first primordial galaxy known to still exist in the universe. But maybe not forever. It may pass another object in the future, or otherwise get disturbed, kicking off the process late in the game. But if not, and this cloud just persists into the distant future, this would become prime real estate for any civilizations left in the universe to try to get to. As the stars of the regular galaxies blink out, leaving a cinder universe, a gas cloud like this would allow for a civilization to persist far longer than they otherwise could by creating artificial stars from the abundant hydrogen of an object like this. Number 7. The Sleeping Artificial Intelligence. Often overshadowed by 2001, the very worthy sequel 2010 shows a scene where HAL 9000 is awakened and is speaking to his creator, Dr. Chandra, who tells him the truth that he will soon be destroyed to save the other members of the expedition. HAL then thanks him for his honesty and accepts his fate willingly. But he asked a very interesting question. Dr. Chandra, will I dream? Sleep to a computer typically is an energy-saving mode and not essential for a computer to run. This is true for AI as well, except as our artificial intelligence advances, it's becoming clear that some form of true analog sleep might end up being useful, and it may even be useful for it to dream, at least in a sense. Researchers in Italy were looking into an issue with AI models, known as catastrophic forgetting, where a previously learned and executed task, as it continues to learn, degrades and is forgotten. You might build a model that can identify different species of shark, but if you teach it to identify different species of frogs, then it may lose the ability to recognize the sharks as a result. They then developed a way for the AI model to sleep and dream periodically to consolidate its memories and basically refresh everything. So when dreaming, the AI will see pictures of fish and other random animals to consolidate its memory, but also false animals that do not exist in nature and are smashed together attributes of real animals to teach it to learn more complex patterns. The models that were put to sleep in this way performed as much as 12% better than those without the ability. But in the end, this is really just taking a page from the human brain and how it works, and the hours of sleep we require may not be what an AI requires. And AIs spending time sleeping isn't really good for productivity. Number 6. The Sleep-Chewing Reindeer. While we're on the topic of sleep, there has been another discovery, and it's rather odd. It's long been known that some species can get to sleep under very unusual conditions in a way very different from the sleep habits of a human. The Arctic is like this, where the period where the sun shines 24 hours a day and food is abundant is not a good time to waste before the sun goes down for half a year. As a result, animals are busy when it's light out. In this case, the Arctic reindeer was noted to actually sleep and chew at the same time, but not actually eat. Reindeer are ruminants, and they chew their cud, which the reindeer seems to do on autopilot while sleeping. The brain waves of the deer indicated sleep. They were harder to disturb when in this state, and actually closed their eyes as though snoozing, all while they were chewing away. This is not the weirdest to be found in the animal kingdom, however. Certain species like penguins and seals can actually sleep with half of their brain, while the other half is awake. Studies such as this, however, could shed light on people that have sleep disorders, such as sleepwalking. Number 5. The chances of AI being our extinction event. Before the launch of ChatGPT, a survey was done of AI researchers asking when certain telltale milestones would be hit in AI development, especially in regards to when AI would be able to outperform humans in most tasks. A similar study involving 2,700 researchers done in 2023 revised these milestones as coming significantly faster by as much as 48 years than they had been predicted in previous studies. AI development is surprising us. It's also surprising in other ways. It was not at all well predicted in years past just what AI would be initially good at. You could see deep fakes coming. CGI has been everywhere for decades, and now AI is just the next step. But what wasn't seen was that AI would basically be able to very rapidly rival humans in art and music. Well, not quite there yet. There will come a time relatively soon where AI will outdo us in an increasing number of tasks. But in some ways, it's already fully capable of being used to undermine political systems, interfere with security, and many other things. But the big lingering question is, at what stage does AI become capable of destroying civilization and bringing about human extinction? A theme in sci-fi for sure, but in the past, specialists felt that there really wasn't much of a chance of it. AI is good at some things, but it's not yet all that great at manipulating its environment, and power can always be cut were the usual arguments for its unlikelihood. Only far future scenarios such as molecular nanotechnology getting hijacked by an AI seemed plausible. But in the new poll, researchers weren't as sure as in the past, and now put a 5% chance on AI being humanity's eventual extinction event. The theme again being, and the most important thing to take notice of right now in technology, is that AI is surprising us. Number 4. Neanderthal cave lion hunting. Over the last 20 years, many new finds have been made that have revised our view of our close hominid relatives, the Neanderthals. Once thought to not be quite as sophisticated as we are, which was a bias, we now know that Neanderthals buried their dead, practiced rituals, and even created art. They were mixing paints from red ochre and manganese, and probably practicing body painting. They were also mixing with anatomically modern humans. A large percentage of human groups bear Neanderthal DNA, suggesting that at the time we probably just saw them as odd-looking humans and vice versa, though that's actually very difficult to establish, given how close the two are anyway. It might have happened from a common ancestor. One interesting thing about this, though, is that they may have sounded somewhat differently. They likely spoke and could communicate with us, but Neanderthals have structural differences that might have made their vocalization palette different from us. So communication between an anatomically modern human and a Neanderthal would have sounded unusual to anyone hearing it for the first time. And had they not disappeared, and I use that term intentionally because there is debate about whether they went extinct or simply absorbed into our gene pool, it's interesting to imagine things like singing Neanderthals and how that might have changed the course of how humans make music. But now the newest discovery regarding Neanderthals is that they took on some very major and very dangerous prey. A recent investigation of a 48,000-year-old cave lion skeleton found in the 1980s shows that the Neanderthals hunting it took it down with a large wooden spear. This reinforces another find of bones from a cave lion paw that show evidence that the Neanderthals had taken the animal's pelt. From the angle of the wound, researchers were able to work out that the hunters approached from behind when the animal was laying on its right side. It's unclear if they surprised it, or if it was weakened in some way, or what the exact circumstances were. Tool marks on the bones show that it was then butchered for consumption. Number 3. A dense planet in the hot Neptune desert. Planet formation is not clean-cut science. Since the study of exoplanets began, it became clear that there are general classes of planets, but within those classes there are a lot of outliers, to the point that some of them we don't even know how they formed. A new example of this is the exoplanet TOI 1853b. This world is about the size of Neptune, but its density is way off. This planet is far denser than Neptune, and actually exceeds the density of steel, though that is an oversimplification of its conditions. The problem with this world is not just in how it became so dense, but also how it did it in the location it's in. The planet orbits its star very closely. Its year is just 1.24 Earth days, and is located in what's known as the hot Neptune desert, where planets like this are very, very rare, suggesting that it's hard for them to form at all, much less end up with a density this high. There is thought to be a physical reason for this. As protoplanetary disks accrete into planetary cores, the cores eventually reach a density in these regions that causes pressure in the disk to move material away from the forming planet. Somehow this exoplanet violated that, however. How it did it is unclear, but there are some ideas. One is an impact and merging of two large protoplanets, but comes with the issue that it's more likely to end up with multiple planets from such a collision than a single large one, but not impossible. The other idea currently on the table is that it's a core from a Jupiter-sized planet that has lost its atmosphere, giving us literally a gas giant core to study. The planet does have some remaining atmosphere, and the study of that might reveal the answer, as a collision would leave a different chemical makeup in that atmosphere rather than a hydrogen-dominated atmosphere if it were once a gas giant. Number 2. Smoke-emitting stars. Over the last 5 years, the night sky star Betelgeuse has been showing dramatic changes in its brightness, to the point of being visible to the naked eye. The reason for this is that Betelgeuse is emitting large clouds of material blocking its own light as we see it. But recently other stars doing something like this have been observed. Known as old smokers, this class of star involves giant stars at the ends of their lives. These kinds of old stars as they age begin to pulsate and show variability, known as Mira variables. As they pulse, they throw off material from their outer layers. These are well known, but a new class has emerged that aren't pulsating when they should be, but instead periodically dim dramatically due to the emission of material from within the star. This can take months or years for the star's brightness to recover, and it remains unclear how these sorts of ejections of material can occur without the characteristic pulsing. One thing that was noted is that these non-pulsing outliers were all near the center of the galaxy, where the concentrations of heavier elements is greater, which may be changing the conditions enough to change the behavior of these stars. Number 1. The virus-like replicator. Replication is the foundation of life, but also things that start to resemble life, but aren't classed as alive. Most famously, this includes the viruses, but there have since been distinct groups of replicators seen. One of these are the viroids, which are far smaller than viruses and were not actually discovered until the 1970s and differ in that they do not have the protein shell of a virus, just a circular strand of RNA. Very surprisingly, a new type of replicator has been found distinct from a viroid, known as an obelisk. These two are very tiny and consist entirely of RNA in a rod-like structure, but unlike a viroid, they actually do code for proteins, and they aren't like any proteins known. Even stranger, the obelisks were isolated from the human gut. This suggests that they have some kind of a role in life, and this discovery opens up more questions than any other science story in a long time. These questions will be: what role do they play in actual life alongside the viruses and viroids? Can we use whatever they do in medicine, and how do they affect health, and many other avenues? But they also have one other potential. The major idea regarding abiogenesis on Earth and how life got going involves RNA, and that the first life was RNA-based. This requires RNA to start with, and that in turn is known as the RNA world, for which evidence is mounting. If that's the case, however, It's possible that the viroids and obelisks are somehow related to the RNA precursors of life and represent relics of sorts of the long ago RNA world. In some ways, that world may still be with us. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently giving a shout out to some friends of the show, Chris of the Eastern Border Podcast and his new wife, Evita. Congratulations to you both, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live. Discoveries and developments in science and engineering continue to march forward. So here are 10 interesting scientific discoveries for December of 2023. Number 10. Getting closer to artificial life. When we think of life, we tend to think of genomes and species in the natural sense. We might also envision alien life that also might work on genetics, but otherwise be unrelated to Earth life. We can also do things like modify genetics in crops as GMOs, but those fundamentally remain relatively simple modifications to a few genes. But there's always been the idea that an artificial life form might accidentally pop out of a test tube in a laboratory looking into the abiogenesis of life. And recent work with artificial genomes in viruses and bacteria have been successful, but now we're moving into territory where it could prove very useful. Scientists have created the genetics for a strain of yeast that features 8 of its 16 chromosomes that are artificial. Yeast is complex, it's eukaryotic, as opposed to bacteria, and it's going to take a year or more to actually create the actual strain. The problem with artificial genetics is that it's extremely complex, and researchers often run into bits and pieces that they think should have no effect on the eventual outcome, but end up affecting it, which is especially a problem for complex eukaryotic cells because they carry a lot of junk DNA. By removing that and streamlining the genome, scientists hope to get past that and gain the ability to create optimized, customized agricultural crops, or in this case, yeast. This is actually so advanced that one of the chromosomes involved features genes aligned all in one direction, which does not occur in nature, at least on Earth. This shows promise, as all work of this type does, in improving human food production. At the same time, however, there are concerns, ones that proved valid with GMO corn, which has escaped due to corn being wind-pollinated, and now appears in the genetics of heirloom corn varieties, that artificial organisms could escape into the environment. The way to fix this is with a genetic kill switch. In the case of this yeast, it's incapable of outcompeting natural yeasts. But with so little known and so many variables, it may later prove a problem if that proves wrong. A brave new world, indeed. Number 9. Mapping all molecules with AI. Molecules can be unbelievably complex things, so much so that not all possible variations are known, and chemists find new ones all the time. But one area where AI may prove to be better than humans are, very quickly, is in mapping new molecules, which could have profound effects on materials sciences and pharmaceuticals. The idea is that molecules can be variants of each other, very similar but not quite. Mapping them would allow for things like having a catalyst with a toxic component to be replaced or edited with the help of another molecule that has a less toxic component. We seem to be at that stage now with AI. So long as you ask it the right questions, it may be able to provide the right answers in discovering new molecules, and do it in hours or days instead of decades, as has been the case. There have already been breakthroughs with AI in predicting protein folds, an unbelievably complex affair. But predicting all possible molecules will be an even bigger undertaking. That probably would not be possible for humans, at least for centuries, without it. Even with just a single drug compound, you can have as much as 10 to the 60th variations. Number 8. The oldest DNA ever recovered. DNA is delicate and usually doesn't survive long after the death of whatever creature bore it. Scenarios like Jurassic Park depict the extraction of DNA from mosquitoes preserved in amber to retrieve dinosaur DNA, but this is not likely in practice. The ancient DNA simply falls apart over time, no matter how good the preservation superficially is, and it's not too likely that we're going to ever find 65 million or more years old DNA. But in rare circumstances, younger DNA, though still ancient, can be preserved. In 2021, 1 million-year-old DNA was recovered, but now, DNA found recently in sediments in Greenland have pushed that back to 2 million years. Greenland at that time was a forest realm rather than an Arctic desert, but it becoming an Arctic desert helped preserve the ancient DNA, which comprises a number of species which researchers are using to reconstruct the flora and fauna of Greenland at the time. The DNA does not derive from fossils, but rather adhering to minerals in the sediment layer they came from. The species found are mostly plants, many of them still around but no longer in Greenland, but they did find DNA of Arctic hares, some sort of rodent related to a lemming, geese, reindeer, and muskrats, and even an extinct member of the elephant family that might be a mastodon species, but not a mammoth. This opens up a weird scenario, however. So if DNA strands can bind to minerals and preserve in cold environments like Greenland, then what of Antarctica? It's been a cold, icy desert far longer than Greenland, but once hosted much older ecosystems, and even dinosaurs, when it was in a very different, warmer position on the planet. Maybe instead of amber, the scientists of Jurassic Park should have been looking at Antarctica. Number 7. Phosphorus at Enceladus. The ice shell moon Enceladus remains one of the best chances in the solar system to host life in its subsurface ocean. Steadily over the last few years, the elements used by life have been identified in its makeup, including carbon, hydrogen, nitrogen, oxygen, and sulfur. There was one missing, until now: phosphorus. Phosphorus in the universe is problematic. Unlike other elements necessary for life, it's been shown that phosphorus may be distributed in a spotty manner, and entire swaths of the Milky Way may as a result be too phosphorus poor to support life. In the case of this solar system, we have a lot of it, but until now it hadn't been measured at Enceladus. Phosphorus is even tricky here on Earth, in that we have it at Earth's surface, but a lot of it is locked away in minerals, and a localized lack of it tends to dictate what places life on Earth can sustain. The phosphorus was found in the Cassini measurements of Saturn's E-ring, which is generated by Enceladus's plumes. They found it to be rich in sodium phosphate, so much so that Enceladus's oceans, where the plumes originate, have 1,000 times greater concentration of phosphorus than Earth's oceans have. This phosphate probably originates in minerals on Enceladus's ocean floor and dissolves into the water. So plenty of free phosphorus at this moon for life to take advantage of. The problem is that the concentrations are so high that if there were life there, it should be getting more efficiently locked up in biology, suggesting that there may be no life there, or it's life that very slowly metabolizes phosphorus. Number 6. The spin of Earth's core is slowing. Earth's core is mysterious. We know it's solid, forced that way by pressure, surrounded by a molten outer core, the mantle, and the crust. We also know the inner core is rotating. In 2009, measurements determined that the inner core was rotating slightly faster than the mantle. New measurements, however, have shown that it no longer is. Its rotation has slowed. Past periods showed that the inner core was rotating unusually rapidly between 2001 and 2003, and again in the 1970s it was different, indicating an oscillation that might be part of a 60-year cycle. This is probably caused by interactions between the mantle and the core. None of them are perfectly spherical, which means they gravitationally tug everything around unevenly. This may explain why Earth's rotation itself can vary, and may also indicate that the Earth's magnetic field is about to undergo a reversal, and may even result in a change in direction that the inner core is spinning. This would have little effect on the surface, however. The changes of a reversal would actually produce a very small effect on Earth's magnetic field, not a huge one, along with an effect on the length of the day by 1/10 of a millisecond per year. Number 5. The smaller sun. Historically, how you measure the size of the sun is by looking at the photosphere, the part emitting the light. One major modern way to do this is through observations done during total solar eclipses, but there are other ways. For example, by studying the sound waves rippling across the sun's surface, you can derive it. These are called F-waves. The problem is a third way of measuring it, by modeling the sun's interior, actually predicts a slightly smaller number, so it was clear that there was something we were unaware of going on. But F waves aren't the only sound waves the sun produces. In its interior, there are also P waves, created by the movement of material inside the star. These waves can actually pass through the sun's core, and strangely enough, the measurements actually support the models instead of the F-wave data. The sun appears to be slightly smaller than we thought, but slightly is a key word. It's off by only a few hundredths of a percent, but it may lead to more precise insights on the interior workings of the sun. Number 4. Electrolocation as a sense versus electrocommunication. We think of the senses in how we as humans perceive them, but we've long known that there are other phenomena in the animal kingdom that may represent entirely different senses. One of these is electrolocation, which is a common ability for some fish, with weakly electric fish generating their own tiny electric field that allows them to sense local changes within it. This is helpful in navigating dark conditions, hunting, and many other applications. One species, however, was a bit of a mystery. The brown ghost knifefish lives in the Amazon River basin and produces a constant electric field at one frequency. Occasionally, however, especially in the presence of another of the species, they will chirp. This was always thought to be a form of animal communication, to attract mates or drive off rivals. But it turns out it may not be. Researchers have found that by changing the fish's surroundings in general, more chirps result. And reproducing chirps played back produced no reaction from the fish, suggesting that the fish are merely electrolocating each other with no role in communication. Number 3. A new look at harnessing the heat energy of the oceans. In 1881, physicist Jacques-Arsène d'Arsenval proposed a method of exploiting the temperature differences inherent in Earth's oceans for power generation. Known as OTEC, or Ocean Thermal Energy Conversion, experiments with this technology met some success, but also failures, but was ultimately overshadowed by the exploitation of inexpensive fossil fuel technologies, and to a degree nuclear. But interest in this very early system of power generation has renewed, especially for use by island nations. Essentially what happens is you use surface water warmed by the sun to heat ammonia or water, which spins a turbine producing electricity. Deeper, colder water is then piped from the deep to cool the fluid and start the cycle over. There is enormous power potential here. We could power the entire Earth with this technique in principle, without altering the ocean's currents. There are already small plants of this nature operating in Hawaii and Japan, and with better technology than what was available in the past, it may be viable on a greater scale now. But where this may become viable very quickly is with islands. Generally speaking, energy is expensive on tropical islands, which tend to rely on diesel generators and other means that keep costs up. OTEC promises a much more environmentally sound and inexpensive alternative to island nations. One hurdle has been constructing the extensive deep-water pipes needed, but alternatives to this are being looked at. Number 2. The 1800 light-year distant planetary collision. In 2021, the star Assassin 21QI dimmed by 95% very rapidly. It became evident on further study that the star had spent the previous 2 years brightening before dramatically dipping. This was a mystery until recently when a model was presented that seems to account for everything that was observed, but represents a cataclysm like nothing ever seen before in astronomy. The likely culprit was the collision of two Neptune-sized worlds in orbit of this star. As they smashed together, it released an enormous mass of vaporized rock, ultimately stretching about 7 times the diameter of our Sun. There would have been a white, superhot remnant remaining, eventually forming a torus of material. But this particular one seems to have been significantly less hot than it would have been had it been from the collision of terrestrial planets. Rather, this seems to have been more like water vapor-rich ice giants like Uranus and Neptune. Now, over time, the material will condense into a new planet. The system, centered around a sun-like star, is thought to be about 300 million years old, so a planetary collision in this system might seem less likely that late. However, it may simply have been some kind of perturbation by a passing star or another planet in the system that put them on a collision course. Number 1. The resonant fossil planets. While star systems, through the luck of the draw, can be violent places that see entire planets crash into each other, it can also go the complete opposite. HD 110067 is one such star system. This one in some ways is a fossil star system that remains unchanged from its earliest days billions of years ago. A recent discovery made with a test spacecraft, within this system are 6 gas giants, which is unusual on its own, which in the data showed up as transits. As the orbital periods of these worlds were worked out, it became clear that these worlds were orbiting in an unusually stable resonance with each other, suggesting that this system has never seen any cataclysmic events or wandering planets to set different resonances. Rather, it preserves the original resonance that its worlds fell into not long after the formation of the system. This opens the way for gleaning new clues about star system formation. Thanks for listening. I am futurist and science fiction author John Michael Godier, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live. The march of scientific discovery continues, and we have begun 2024 on a high note. So here are 10 interesting scientific discoveries for February 2024. Number 10. Atmospheric metal from satellites might be a problem. When we think of deorbiting satellites that have ended their service life, it's usually seen in the context of getting it out of orbit, at least to try to keep low Earth orbit as clean as we can. That doesn't always happen, of course, but the concept of mitigating space junk is only going to become increasingly important in coming years, with the dramatic expansion of satellite technology. With any number of coming satellite constellations like Starlink that will markedly increase the amount of satellites in orbit. As these numbers increase, however, so will the amount of satellites being deorbited. That's usually considered harmless, but do it enough and you'll increase the amount of vaporized metal in the upper atmosphere. There are 2 sources for this right now: satellites and meteoroids. An aircraft-flown instrument known as PALMS, operated by the NOAA, measures the concentrations of metals in the atmosphere using lasers. The thing is, satellites and meteoroids are made of different metals typically, with satellites showing one metal that meteoroids usually do not: aluminum. And it turns out that about 10% of the particulate matter in the upper atmosphere contains aluminum from spacecraft that have burned up. This isn't enough to mess with the stratosphere in any detrimental way, but as satellite numbers dramatically increase, we could get to a point where there is an effect. This is particularly important with cloud formation, where ice crystals tend to form around nucleus particles. This could be a problem in polar regions where stratospheric clouds can affect the ozone layer, but also conceivably with enough particulate matter and resultant cloud cover, it could slightly raise Earth's albedo and cause a cooling effect, which incidentally is one plan for mitigating climate change in a worst-case scenario. Number 9. Artificial intelligence and antibiotic research. One of the biggest challenges in medical science today is the problem of antibiotic resistance in infections. This is becoming a huge problem. But the good news is that there are a staggeringly huge amount of ways to look into creating new antibiotics. Researchers at MIT and Harvard are using artificial intelligence to weed through this. But what happens is the AI analyzes all of the possible compounds that could be antibiotics and then determines which ones actually chemically do work. But it also determines why. Starting this actually required testing over 39,000 compounds on Staphylococcus aureus and human cells to create the training data for the AI, which gave it its training base and a reference of what effects the compounds have on cells. It was then unleashed on 12 million potentially useful compounds, and it found over 3,000 potentially useful antibiotic compounds, finding 2 in particular that are interesting because they seem to be fully non-toxic that we were previously totally unaware of. Studies in mice with the 2 compounds showed that they did have the intended positive effect, opening the way for a vast expansion of classes of antibiotics that will go a long way in combating resistance, a real problem today, especially in hospitals. Number 8. Title locking may not be so rigid. One of the main concerns within astrobiology and exoplanet research is the idea of tidal locking. Planets in red dwarf star systems that lock into place due to the gravity of the star and only show one face to it, which it bakes. And then the other face sits in permanent night. This seems to be bad for life overall. Too hot and too cold at the same time. But there are sweet spots at the terminators of these worlds that might be clement enough for liquid water, at least with some of them. And there are also ideas of heat convection that might make the night sides warmer than might have been thought. Researchers at the University of Nevada, however, have found that in certain circumstances in the modeling, a tidally locked world can actually rotate occasionally and change the day-night situation before returning to lock. And they can do it relatively frequently. The question is, how long would those planets stay in a rotational state during the flip? And again, the modeling shows that it could do so for a substantial amount of time. It seems that it could form a stable climate outside of the eyeball terminator zone and increase the planet's habitability, or allow for abiogenesis that can retreat back to the terminator during periods of full tidal lock. Such constant change in climate on that scale probably wouldn't be able to handle it for complex life. But microbial life on Earth has shown a resiliency to change that might bolster the case for the habitability of tidally locked worlds. Number 7. The monkeys that spontaneously started using stone tools. This one is just outright odd. Primitive stone tool use is seen in several groups of primates. It's not just limited to humans. The species in question here is native to Thailand and is known as the common long-tailed macaque, which can use stone tools as hammers and anvils to crack open oil palm nuts for food. There was one group, however, that were native to an island in Thailand that was a popular tourist destination. This particular group of monkeys didn't use tools because they were well fed by the tourists. Then came the pandemic restrictions, and the tourism stopped flat as a result. The island was actually not only inaccessible for tourists, but also researchers. When they returned in 2022 and last year, in the intervening time the monkeys had developed or redeveloped tool use and were using rocks to crack open oysters. And it wasn't just one monkey, it was at least 17 of them, all doing it the same way. They'd pick up a rock and throw it at the oyster bed. It seems that tool use is driven by incentive. If the monkeys have no need for it due to the tourist feeding, then they don't use tools. When that dries up, they seem to rediscover tool use out of necessity. It's uncertain what drove this. If it was something one monkey figured out one day and the others learned, or if it's something instinctual, we may never know, because the tourists have since returned along with the food. Number 6. Finding missing birds with their song. Extinction is a funny thing, because in some ways it can be difficult to prove. There have been a number of cases where species have been thought to have recently gone extinct, but then were found again. This happens with the fossil record, an example being the dawn redwood, which until 1944 was believed to be extinct until they were discovered still growing in China. A more recent case of this is the purple-winged ground dove, native to Brazil, Argentina, and Paraguay. No one knows if this bird still exists. We only know that it recently did. In 1985, incidental records of these birds' songs were captured during an interview of a breeder that had several of them. Cleaned up and isolated, these recordings may allow scientists to use AI to comb through recordings of the habitat of this bird that were made in 2021 and 22, where 100 recorders were developed that sample ambient sound for 1 minute at intervals of about 10 minutes. If this bird still exists, this technique may allow for its rediscovery without the need for hit-or-miss expeditions to try and spot one. Number 5. The early barred spirals. One of the many new finds of the James Webb Space Telescope include galaxies that are too early to have formed according to our current models of galaxy formation. But that hasn't been the only surprise. Hidden within the JWST story so far is another instance where galaxies are being seen at states that are surprising. The Milky Way is a mature galaxy known as a barred spiral. This common subset of spiral galaxies is actually a very efficient way for a galaxy to work. When the bars form after the overall initial formation of a galaxy, They serve to funnel material into the central bulge of a galaxy, and both feed its supermassive black hole, but also bolster efficient star formation in the best region of a galaxy for that. The thing is, it should take a significant amount of time, billions of years, for a bar to form in a galaxy. But Webb is showing galaxies with bars that had them just 3 billion years after the Big Bang. That's not impossible, but it's surprisingly early, adding a further oddity to the growing basket of galactic oddities JWST is seeing, hinting that our ideas about galaxy formation and how long it takes may not be an accurate picture of what actually happens. Number 4. The wooden transistor. Some materials and technology are better than others. Few inventions of the 20th century have been as revolutionary as the silicon transistor. Silicon is so good that you can cram billions of them into a small computer chip, and they are partly responsible for you watching this video. But silicon is not the only material you can do this with. It's just that other potential materials aren't as good for that application. Researchers have recently developed a transistor made from wood. These transistors, which do work, are huge, like 3 centimeters huge, and they are slow. They take seconds to switch on and off, whereas silicon can do it billions of times a second. The thing is, however, there is a budding field of research into electronic plants, where you can do things like monitor the health of crops using electronics built from the plant itself. The advantage is that they could be completely biocompatible and allow for very specific monitoring of forestry and crop stresses that could prove really useful for those applications. How this work was done was by removing the compound lignin from balsa wood. This made room in the water-moving system of the plant. They then filled that room with a polymer and then added electrolytes that were conductive. Voila! They successfully built a wooden transistor that actually works. What that polymer means for biodegradability remains an open question. Number 3. Amino acids can exist at Venus. Venus is a very strange world that in some ways it actually hints that it may have microbial life in its upper atmosphere that might offer a better chance at that than even Mars does. Venus may be absolutely horrible on its surface now, but there was a time where it may have hosted oceans, volcanism, and other ingredients for life to have once arose, but now may eke out a meager existence in its upper cloud deck, which as far as temperatures and pressure is the most Earth-like environment in the solar system. This scenario, while plausible, suffers from the fact that the solvent at Venus is not so great. It's sulfuric acid, and it's unclear how life could coexist with it, or even be based on it. A start into looking into this would be amino acids at Venus. Sarah Seeger and others at MIT looked into seeing if the 19 amino acids used by life on Earth could survive in that environment. It turns out that 13 of them had no problem, and the rest survived but underwent modification, but not destruction. It also turns out that the nucleic acids that make up DNA also survive high concentrations of sulfuric acid. At the same time, the issue of life at Venus is hotly contested, no pun intended, and remains unclear if there is anything there, or if all the accumulating indicators are being misread. Only a life-finding mission to Venus will answer the question, which is indeed being planned. Number 2. The heaviest element detected in an exoplanet atmosphere. An ultra-hot Jupiter exoplanet known as Mascara 4b has shown the heaviest detected element in an exoplanet atmosphere to date. This exoplanet's atmosphere was characterized using a very large telescope in Chile using starlight. It was filtering through its atmosphere during transits. This one, as many of these types of exoplanets do, showed barium in its makeup. This is not considered unusual. Most planets should have these elements in their makeup, but they really should not be easily detectable. So for some reason, these cases show more of the element in question than would be expected. The new heaviest element seen, however, is the significantly heavier element samarium, which should be sinking into the core of the gas giant and thus not be visible. Samarium under heat like that should also be reacting with water vapor and oxygen, suggesting that these are not present in high quantities. Why this is remains unknown, but there are a number of chemical or physical options on the table. It may just be that the atmospheres of these hot worlds convect in ways that we are unaware of. Number 1. The possibility of quantum life at Titan. Saturn's moon Titan is beyond enigmatic. Out of all of the bodies in the solar system that we've actually landed on, it is the strangest because it's the only other body besides Earth that has liquid on its surface. But it's not water. Their water is a surface rock. Rather, it's low-temperature liquid hydrocarbons, such as ethane and methane. We also know that it has the prebiotic chemistry of our type of life. So it has a solvent and the building blocks, but it does not have the temperatures for the chemistry of life on Earth. Yet it does hold the potential for life as we do not know it, but can envision. At an average of negative 179 Celsius, the surface of Titan just doesn't have enough available energy, such as heat, to support most chemical reactions. The thing is, though, there is another mechanism to get through this barrier: quantum tunneling. We know this phenomenon exists, we use it in electronics, but it also does occur in nature commonly. And it's possible that chemical reactions that life may use could harness this effect in an environment like Titan. But it would be very different chemistry, probably occurring at a much slower rate than it does on Earth. But it remains a possibility. Thanks for listening. I am futurist and science fiction author John Michael Godier. Be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular, in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live. Science marches onward and upward, and the new year promises no shortage of developments in science. So here are 10 interesting scientific discoveries for January of 2024. Number 10. The shark that smelled in stereo. 365 million years ago, a shark evolved the ability to essentially smell in stereo, making it the first member of the shark family that could do so. This ability is still around. Hammerhead sharks, for example, have a wide spacing between their nostrils that allow them to localize prey more easily. This new shark, found in the fossil record of the Sahara Desert in Morocco, likewise shows evidence of this ability. But in this case, this is the most primitive and early example known that possessed it among the sharks and cartilaginous fish. Stereo abilities are extremely useful and are a common biological feature. 2 eyes give depth perception, 2 ears aural perception, and again, here the case is smell perception to zero in on the prey. That this evolved underwater is amazing on its own. The sense of smell, both in water and air, work very similarly. You can detect molecules in these mediums. Sharks do this too. They can smell molecules dissolved in seawater, most famously those that make up blood, but not as distantly as is often cited. It's limited to about a quarter of a mile in the best cases, and while their sense of smell is far better than a human's, it's not that different from most fish. And shark attacks are rare, with many species either being too small or simply not aggressive enough to present much of a problem. Moreover, if a shark smells blood from a quarter of a mile away, it's not too likely to investigate, as by the time it smells the blood, it's going to be faint, and whatever was there is probably long gone. Meaning that while blood in the water leads to a shark attack is true in a sense, it can also be misleading. Most of the time, a drop of blood doesn't lead to an attack, unless there is a lot of it, as in chumming, and it seems worthwhile to check out by the shark. But if it's right on top of you and it's on the attack, if it's the right species, it can smell exactly where you are, even without the blood. This ancient shark was among those species, and it could do it hundreds of millions of years ago. Number 9. Penguin naps last just 4 seconds, with a catch. The chinstrap penguin is a well-known wide-ranging southern bird that can be found in Antarctica, surrounding islands, but also even southern Chile and Argentina. Each year, it comes time to incubate the eggs. The bird's mainline predators are the leopard seals, which will attack them directly. It can actually reduce the populations of those birds in certain areas by as much as 20% during a year. Obviously, this means reproduction is highly important for this species, and eggs and infants themselves have many predators of their own. Interestingly, this seems to have led the adult male chinstrap penguins to have developed a very peculiar sleep cycle when incubating. They only take naps, which on average have a duration of just 4 seconds, but they do it 10,000 times a day. The reason for this is probably pretty obvious: to stay alert and on the lookout for egg-hunting seabirds like the skuas that specifically seek out penguin eggs. Perhaps we should alter the colloquialism catnap to penguin naps, because they seem to be the apex nap-taking species on planet Earth. Not to mention, they are among planet Earth's snazziest formal dressers. Number 8. The color-changing nebula. Researchers from Brazil using the Vista telescope in Chile's Atacama Desert were engaging in a 9-year search for signatures of past supernovae. During this search, one single nebula was displaying anomalous behavior, unlike any other known nebula in the Milky Way. This nebula is changing colors for unknown reasons. The nebula is near an anomalous object known as VVV-WIT-12. The WIT part in that catalog designation stands for "What is this?" and the catalog comprises a list of objects that aren't quite classifiable through normal means. In this case, we may be actually seeing a very young, newly formed star exhibiting variability, which is reflecting off the nebula, causing it to change color, but also cause variations in brightness over a 4-year term. Further study with the coming Vera Rubin Observatory should allow for more in-depth study and a better understanding of star formation and nebulas. Interestingly, as an aside, if that is indeed the case, then it's a very short-term transient phenomenon that we just happen to catch. But it's possible that most nebulas do this for a time just after new stars ignite and begin fusion. Number 7. The ice supervolcano of Pluto. There's no question that Pluto is an enigma. What was once thought to be a frozen wasteland with not much going on revealed itself as a dynamic world with some very young-looking surface features indicating active geology. Recent studies of the New Horizons dataset, however, have revealed something peculiar that may explain the freshness of Pluto's surface. An ice supervolcano, the size of the Yellowstone supervolcano here on Earth. Known as Kiladze Crater, the feature on Pluto seems to be cryovolcanic rather than an impact structure, and may have ejected enormous amounts of material onto Pluto's surface just a few million years ago. Interestingly, the surrounding ejecta appears to be chunks of frozen ammonia and water ice. This is particularly interesting because the hypothesized subsurface ocean of liquid at Pluto predicts just such a mix of ammonia and water. It's uncertain if such a mix could be a solvent for life, but it's interesting nonetheless. Pluto could be an ice shell every bit as habitable as Europa or Enceladus, sporting the same general sorts of active geologic processes. Number 6. Ancient Antarctic valleys locked under ice. Glacial ice is usually the ultimate in landscape-changing forces. The ice ages in their wake left huge tracts of land scoured, along with deposits of silt and rocks transported over huge distances that are evident in some areas to this day. Antarctica is no stranger to this process, with many of its glaciers slowly moving like a conveyor belt. But Antarctica wasn't always like that, and had in the distant past hosted dinosaurs and much warmer temperatures. As it migrated, however, it froze and glaciated, leaving its topography forever changed and scoured, except in one spot. Under the East Antarctic ice sheet, studies using radar measurements from satellites have identified one area where instead of the scouring, the glaciers just locked onto the landscape and didn't move. This preserved area consists of valleys and preserved fjord structures, along with the action of former rivers. The preserved topography is believed to have been covered in ice for at least the last 34 million years, leaving a buried but preserved landscape from the Paleogene period. Number 5. The highest energy pulsar. Pulsars are extremely energetic, rapidly rotating neutron stars that emit beams of radiation into space. How this works is that rotating pulsars, which can spin hundreds of times a second, tear charged particles from known surfaces, inject them into the pulsar's very powerful magnetic field, and that directs them into beams at the poles. This process typically emits energies at around 1 trillion electron volts. That was until measurements from a pulsar in the constellation Vela upset that by being about 200 times more powerful than any other pulsar so far measured. It's unclear how that's occurring. Very highly energetic particles were measured coming from its direction, leading scientists to suspect that the pulsar's magnetic field lines are somehow disrupted and may have temporarily snapped, sending out a hail of unusually energetic particles. But if that's the case, then the pulsar should soon recover and return to emitting lower energy. If it does not calm down, however, it could signal new physics. Number 4. Roads on the Moon. It's hard to forget seeing the astronauts of some of the Apollo missions driving their lunar rovers, kicking up dust and bouncing around in the low-gravity environment. That terrain was rough, but if we are to ever colonize the moon, that level of trouble and transport could be a problem. Researchers in Germany recently used a powerful laser to melt simulated lunar soil and see if it would be suitable to create paving slabs that could be used to pave roads on the moon to facilitate future transport better. It turns out if you heat the lunar soil to 1200 degrees Celsius, it will melt and form a black material, very comparable to concrete in its properties. Actually instituting that would be an issue. You'd need to put a giant energy-hungry laser on the moon. But the researchers also found you could do it with a 1.5 meter lens, focusing and concentrating sunlight on the surface of the moon, which is eminently more practical. Interestingly, unlike roads on Earth, any lunar roads we build are sure to still be there billions of years after we first constructed them. Maybe they will be among the last artifacts of humanity to disappear. Number 3. Shipwrecks are useful. It's long been known that when a ship sinks in the oceans, it will be colonized and used by life. Indeed, the Titanic is slowly being eaten by rusting, iron-consuming bacterial colonies called rusticles, and is home to all sorts of deep-sea ocean life. We even intentionally sink ships sometimes as artificial reefs and diving destinations. And other than just a few places in Earth's oceans that are either too cold or too anoxic, wooden ships do not survive intact on the bottom of the ocean for long because they get colonized by wood-boring teredo worms. But now it's recently been found that shipwrecks are useful in another somewhat unexpected way. Fishing through bottom trawling tends to wreak havoc on oceanic ecosystems, often basically harvesting everything in their path, including sea life we don't eat. The thing is, fishermen using bottom trawling try to avoid shipwrecks because they endanger their equipment. Scientists recently took a look at shipwreck sites off the coast of Scotland in an otherwise very active fishery, and found that the shipwrecks were providing oases for sea life. It's possible that this may actually be helping the fisheries recover their populations, and that more intentional shipwrecks are desirable, along with the protection of old ones as a new tool in marine conservation and fishery management. Number 2. The pristine star system. Star systems are dynamic, especially early in their history. Our own star system saw much planetary migration before settling into its current resonances. Much rarer are star systems where this does not occur, and the member planets are basically in the same situation as when they first formed. This seems to be the case with the star HD 110067, which hosts 6 exoplanets, all of them in the sub-Neptune class, which sits between Earth and Neptune in size. The planets are in such a resonance that it's suspected that they are unchanged from their formation a billion years ago. Discovered by TESS in 2020, and later also studied by the Cheops satellite, the system showed dipping patterns inconsistent with what was expected, leading to the discovery of all 6 planets, and also determining their unusual, very rhythmic resonance. The planets are very close to their star, so it's likely that they are extremely hot on level with Mercury and Venus. The system promises to shed light on planet formation in protoplanetary disks, as well as how sub-Neptune worlds form. The star they orbit is Sun-like, but the planets are very different from what we have. They also appear to be low-mass planets, suggesting gas atmospheres or water-rich, deep interiors. The next step is observations with the James Webb Space Telescope to try to characterize these worlds further. Number 1. The high-energy cosmic ray from nowhere. In 1991, the most energetic cosmic ray ever observed, known as the Oh My God particle, hit Earth's atmosphere and was detected by the Fly's Eye experiment at the University of Utah. This particle hit with the power of a thrown baseball, and was so powerful that no one has been able to identify a source extreme enough to have created it. Strangely, while many other high-energy cosmic rays have been detected since, none were anything close to the power of the OMG particle. Until now. And it's deepened the overall mystery. Researchers in Japan have detected the second most energetic particle ever seen, and it's in the same class as the OMG particle. These particles are sufficiently powerful that scientists can determine what direction they came from, whereas with weaker particles, magnetic fields in space can obscure their origins. They were able to trace the OMG particle back to an origin point, but there wasn't anything in the area powerful enough to have produced it. This new particle, known as the Amaterasu particle, is actually worse in this regard, because its origin is even more puzzling, because its originating space basically contains almost nothing at all. It came from the local void. Interestingly, the two particles were detected using two separate methods, proving that these things are real and not instrumental flukes. Even a supernova is not powerful enough to accelerate these particles. And the other issue is that particles have a hard limit as to what they can sustain as they cross space and interact with radiation, and these particles violate it flagrantly. What their origin actually is remains unknown, but could strongly be hinting at new physics of which we currently have no understanding of. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently mildly concerned that the penguins aren't getting enough quality sleep. As if living in Antarctica wasn't hard enough, you can't even get any good sleep down there either. Planet Earth, I'm telling you. And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live. Well, it's been a busy month for science, leading to much material for Science Story aggregate videos for June. There was so much that there will actually be 2 of these lists this month in order to cram it all in. So here are 10 interesting scientific discoveries for June 2024, and expect part 2 in a day or two. Number 10. The Red Asteroid. In 2021, an enigmatic asteroid termed 469219 Kama'oluyua, I think we can safely reveal that it was the University of Hawaii and Pan-STARRS again, that actually orbits on the same trajectory as Earth. That's always going to be interesting because it's really an open question about material getting knocked off Earth by impacts in the past, and how incredibly interesting it would be to see what that looks like. But in this case, there was another mystery. The asteroid is reddened in an unusual way, not quite like other near-Earth asteroids. That reddening led to work being done on just what body in the solar system has the surface chemical composition to do that and still have it in that odd orbit. As it turns out, it matches the moon, so this asteroid is likely to be a chunk of the moon blasted off by an impact. But it's recently gotten more interesting because now researchers think that they know which crater it was. Renu Malhotra at the University of Arizona and colleagues found that the crater needed to produce it should be between 10 and 20 kilometers in diameter, and recent, as in formed in the last few million years. The lunar farside crater Giordano Bruno fits the bill best, being both the right age and the right size. But that's where this story takes an interesting turn. Kama'oluyua is slated for a visit and sample return mission by China, with their scheduled Tianwen-2 mission, which is planned to launch next year. That should answer the question and tell us the origin of this weird asteroid. Number 9. Wasps can recognize wasp faces. Certain cells in the human brain and primates in general are associated with the ability to recognize a face. Oddly though, and in a seemingly new example of convergent evolution, wasps appear to have similar cells and a similar capability when looking at members of their own species. On its face, that may seem weird, an insect that can recognize other members of its hive essentially. It's thought that the way wasps do this is at least partly by recognizing differences in color, which is very subtle on other wasps' faces. The species in question is the northern paper wasp, which anyone in much of the US and southern Canada are going to know well. It's very common, and it's been previously associated with also being able to recognize its own nest in a very complex way. The researchers connected up 18 female paper wasps with probes inserted into their brains to record neuron activity. They then showed the wasps a series of thousands of different images. Yes, they had wasps watching television, and they looked for what images elicited a response. Whenever they saw a wasp face, a very specific group of neurons fired in a very similar way, but very different from that when seeing a picture of something else. As to whether this represents a new example of convergent evolution in two radically separated species, the ancestors of we and the wasps diverged long ago, is an open but interesting question that only further research will shed light on. Number 8. The plasmas of Mars. The idea of a coronal mass ejection from the Sun is well known. Indeed, last month, many were treated to a show of aurorae as a result of one. They work relatively simply. Plasmas made of ionized gas inside the Sun's magnetic field can see the field snap in two, leading to bursts of energy that ejects the plasmas into space. Here's the weird thing. Mars does this too. Mars's ionosphere is also filled with plasmas, and even though it only has very weak, spotty magnetic fields, it can do it. It's often said that Mars has no magnetic field at all, but this is a misunderstanding. It doesn't have a core-generated one like the Earth, or a massive one like the Sun generated from beneath. Rather, Mars's spotty and weak field is generated in the crust. This was always thought possible with the ionosphere of Mars, but very difficult to observe. But a group of researchers in Taiwan have done it. Essentially, interaction with Mars's spotty fields by the solar winds causes the same snapback effect that launches plasma into space. These are not huge, they are many times smaller than the Sun, but it really is the same principle, opening the way up for such interactions to be identified in moons and planets, such as Venus, that also lack a global magnetic field. Number 7. Zeroing in on whale language. I think one of the most common thoughts that wander through the heads of the science-minded, as anyone watching my content probably has wondered about, is whale language, which I have wondered about since I was a kid in the 1980s. How can you not? They appear to be speaking to each other somehow, but in a way so different from what we humans do that we haven't really been able to figure out much about it, even across decades of people studying it. In fact, the mystery of whale language has only deepened. It turns out that new research is showing that whale song is actually the closest thing to human language yet discovered in the animal kingdom. In other words, in some ways, they speak more like us than any other species we know of. The study looked at the communications of East Caribbean sperm whales, Physeter macrocephalus for the taxonomically minded. But it's more than just whale song, but also the clicks they make that show a very complex communication system. But we do that too. Human languages cover all sorts of varying sounds, including clicks, or sometimes termed kicks in some of our languages across the blue jewel. With the whales, some of their behavior is very similar to ours in addition to vocalization, in that they tend to have family units that hunt together and coordinate. In their context, not all that different from early modern humans. They hunt together, dive together, and do all sorts of interesting coordinated activities. So the sperm whale click patterns are classified into codas, and there currently are 21 different known patterns. This is from a sampling of 9,000 sperm whale recordings. They found some strange things. For one, they found that there was a correlation between extra clicks at the end of a statement, if you can apply that term, signaling that it was time for the other whale to speak. They also noted that the whales would slow down codas while maintaining their rhythmic patterns, not unlike stretching out a song lyric or the last word of this video. And they would also string codas together as though they were words, along with varying the tone and complexity, vaguely recognizable perhaps as an analog to letters in human languages. The bottom line is we can say the whales are speaking. It's not just calls. What they are saying, however, remains a mystery. Number 6. The invincible robot hand that trains AIs. This is one of those developments in technology where you just throw your hands up and say, well, of course we needed that. AI is safe. Work at Google DeepMind and Shadowhand has created a virtually indestructible robotic hand that can grasp an object with considerable force within half a second, all while being able to survive blows with a hammer. The hand is used to train an AI as it fumbles around physically moving objects and learning its environment, perhaps while it simultaneously works out how to trick us into virtual reality so it can use us as living batteries, and helps the AI learn through trial and error in the physical world. In all seriousness, there actually is a reason for this. It's actually both a testament to nature and how humans and animals do this so easily, and how difficult it is to train an AI to do even the simplest physical interactions. This hand has to have hundreds of sensors, some of them measuring deformation of the silicone covering of the hand to simulate how we feel pressure. To reach this level of complexity for an AI that doesn't even have all of the capabilities of a paper wasp otherwise. AI is scary. There are, at the very least, cybersecurity and deepfake concerns, but it's going to get really scary in the future in ways that no one is currently anticipating. Number 5. Einstein was right again. There are a few environments in the universe as violent, hellish, and outright outlandish, yet it exists, than the environment of the accretion disks of black holes. In these disks, particles are moving at very nearly the speed of light. Time is extremely slowed down for these particles to the point they're barely experiencing it, swirling around the black hole and spiraling in. Einstein predicted through general relativity, however, that there comes a point where the particles simply stop and fall into the black hole. Known as the plunging region, it is located just above the event horizon of the black hole. Again, the plunge happens at very nearly the speed of light. We often talk about spaghettification. If you fell into a black hole where the atoms of your body would be stretched into a straight line of infalling material. But it's worse than that in reality. It would be doing so at high relativistic speeds. Do not get near the accretion disk of a black hole without taking proper precautions. A good one being, don't go near the black hole at all. For the first time, the plunging region of a black hole has been detected by a team led by Andrew Mummery at Oxford. General relativity was correct once again. The particles can be likened to a river with a waterfall at its end. The water flows along while it's a river, but abruptly falls when you get to the waterfall. So instead of slowly just spiraling in, there comes a point where everything just drops. It's actually rather amazing that this was detectable at all, through surplus of light from the black hole's accretion disk, which was a black hole known as Maxi J1820 plus 070, which is around 10,000 light years from us. And it was not previously thought that this particular proof of general relativity could ever be verified, but it was. Interestingly, this work may help solve another outstanding mystery about black holes. So they produce an X-ray as a signal that suggests that black holes can spin faster than theoretical predictions suggest. But with the discovery of the surplus light, photons, from the plunging region, it may shed light on why they appear that way and close the discrepancy. Number 4. Oldest known human infectable viruses found. DNA from several male Neanderthal skeletons found in Shagarskaya Cave in Russia was studied, and researchers were able to isolate viral DNA and see what the Neanderthals were suffering from as far as viruses. It turns out the Neanderthals were suffering from many of the same things we still do today. They found an adenovirus, which is one of the viruses that cause the common cold, along with the herpes virus and HPV. Interestingly, the DNA is similar, but yet not similar to modern versions of these viruses, which help confirm their age, but also eliminates the possibility that the DNA was contamination from predators or modern handling. This actually takes a dark turn, because a body of previous work seems to suggest that infectious disease played a role in the extinction of the Neanderthal, though in fairness some of them were absorbed into part of the human genome. And it really does look human in its profile. The average person today will get about 10 species, and many more strains of viruses across a lifetime. So to find 3 in a Neanderthal isn't unexpected. There is ongoing work to try to further reconstruct these ancient viruses, but that's going to be really challenging due to the incomplete nature of ancient DNA, and of course concerns about bringing back strains of human infectable viruses from the past are warranted. Number 3. Frozen brain tissue revived without damage. One of the biggest issues in the field of cryogenically freezing humans for revival in the future seems to be solved. When you freeze tissue, brain or otherwise, the big problem is that the cells get damaged, literally torn apart by the crystals of ice. There has been some progress with this in the form of vitrification and sort of soft freezing tissue, but the brain has remained elusive. It gets damaged no matter what, and it's unclear how to repair it, or if that's even possible, but there may be a fix. Researchers in China have managed to grow brain organoids, basically a clump of self-organizing cells that turns into neurons and other brain cells, and were able to freeze them in various compounds, which was key, basically sugars and various antifreeze compounds, using liquid nitrogen, and then thaw them out and see if any function was preserved. It turns out the best compound for preservation was one that inhibits the pathway that usually results in cellular death. They got similar results from actual human brain tissue, furthering the possibility of dramatic life extension through cryonics, as well as possibilities for freezing astronauts during interstellar voyages. Number 2, the impossible star wasn't impossible. In 2019, a star known as KIC 8145411 was discovered that was not normal for a white dwarf. It was found to be orbiting a second sun-like star and in an unusual position from our point of view in that it eclipses and gravitationally lenses the sun-like star's light, allowing for the mass of the white dwarf to be accurately calculated. It turned out to be too small for a white dwarf. Very small white dwarfs do happen, but only if the companion star is sapping material from them. And in the system, the two stars were simply too far apart for that to happen, leading to a situation that shouldn't be, since there is no other mechanism to get a white dwarf with those characteristics. It turns out it was an illusion, and there was a third star present in the system skewing the data. And the white dwarf is now calculated to be well within the normal parameters for a white dwarf. Number 1. Quantum entanglement survives chemical reactions. Chemical reactions are not peaceful things. Exploding dynamite and fire are chemical reactions occurring very rapidly and in some ways chaotically. The products of the reaction basically just come flying out of the reaction, and the whole thing is just violent on its scale. This led researchers to wonder if quantum entanglement could weather such chaos, and two particles come out of it still entangled. Researchers took atoms of rubidium and potassium and collected them in a vacuum, dropping to near absolute zero temperatures, where they combined into molecules randomly. All through this, the scientists monitored their individual quantum states to see if anything changed. To put it another way, they looked at the coherence of them, meaning that they were in a wave state when the whole thing started. If the reaction had affected them, their waveforms would have collapsed. They did not. They remained waves, suggesting that entanglement and certain quantum states can maintain themselves in a chemical reaction. This actually is potentially more important than it might initially sound because it opens a certain door, which is the control of quantum particles in a very practical way. Thanks for listening. I'm futurist and science fiction author John Michael Godier, and when I have time, old school fossilized 90s gamer that's still waiting for a decent sequel to Bard's Tale and an update for Windows XP. I'm also eagerly awaiting the new Columbo or Seinfeld episode on television, so I often get asked by the gaming audience. So, JMG, alright Gen X proto-boomer, what games are you currently playing these days? And it's Helldivers 2 on PS5, simple fun. And I mean, who doesn't dream of expanding the human empire to the entire cosmos? And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular, in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live. The march, see what I did there, of scientific discovery continues in a dizzying variety of fields. So here's a selection of recent scientific discoveries for March of 2024. Number 10. Ending the re-entry blackout. One of the odd quirks of the space age is the communications blackout that occurs when manned spacecraft re-enter the Earth's atmosphere. The reason this happens is re-entry itself. As a capsule or spacecraft comes in, it slows itself by friction, decelerating as a result of it. This is good for slowing down, but bad for communications because an ionized plasma forms that basically creates a sheath that radio communications can't get through. This has been scary in the past because it leaves several minutes where you have no contact with the astronauts and no way to really know what's going on during that last phase of re-entry. If you take a SpaceX Crew Dragon, this can last for as long as 7 minutes. Interestingly, this effect is most famous for spacecraft, but also affects anything going very fast through the Earth's atmosphere over Mach 5, a problem for those designing various unmanned hypersonic systems. SpaceX, however, seems to think they have a fix for this persistent problem of the space age, in that they believe that instead of trying to send signals to the ground, the spacecraft might be more easily able to transmit them to space for relay back to the ground. SpaceX is currently testing this idea, but plasmas are very fickle in this regard, and it may need a lot more nuanced development. Number 9. Sensing warmth with prosthetics. Prosthetics have come a long way over the last 20 years. While it's still a challenging field, with many different factors that affect how they can be used, one general trend has been to try to get them as close to the functionality of what was lost as possible. One holy grail here has been how to translate sensation from a prosthetic limb to the brain. While there has been progress on touch itself, a new device called MiniTouch now takes this closer, in that it is fitted to existing prosthetic hands that allow the user to sense temperature, which has been a problem, both hot and cold, with high accuracy, which actually allowed some enhanced ability to sense materials themselves. Users could also in some cases identify if they were touching someone's arm or an artificial surface. There remains much work and advancement to do before a truly perfect prosthetic can be produced, but any advancement is a welcome one. Number 8. Cosmic dust may have played a role in abiogenesis. One of the great mysteries in trying to figure out how life arose on Earth has been the problem of Earth being relatively poor in certain elements needed for biochemistry. It was unclear how Earth accumulated materials like phosphorus and sulfur, but one idea that was largely discounted in the past has made a comeback. It's that the materials were delivered by the constant rain of cosmic dust that falls to Earth. The reason this was previously discounted is that as a whole, not enough cosmic dust accumulates in any one area of the Earth to account for it, even though there was much more of it in the past. Meteor showers on early Earth must have been spectacular. Until recently, however, this has led the focus to look for larger meteorites that can deliver larger amounts of these materials at once. But there were problems with that idea as well, in that it seems that you need a constant supply, which meteorites just don't provide in any one place on Earth. Recent simulations have solved this issue in that the researchers were able to show that dust falling on glaciers can be conveyed to melt zones where the materials can accumulate in melt ponds at the edge of a glacier, providing the concentrations that life would need to get going. Unfortunately, however, it's also unclear whether early Earth during the time of abiogenesis occurring even had glaciers. Number 7. Transmitting power from space. One of the issues with solar energy is that it cannot be generated 24/7, due firstly to nightfall, and secondly cloud cover, meaning that it is an imperfect but important power source here on Earth. But it's been envisioned for many decades that space-based solar power generation would defeat both of these problems, and turn solar into a permanent, uninterrupted power generation resource. The problem of deploying such a system has been twofold. Firstly, you have to build a large enough solar panel to be meaningful, but still small enough to be launched on a rocket. And second is the issue of getting the power down to the surface of the Earth. One way of getting past the size problem is to assemble the structure in space using many flights, or alternatively sending up a constellation of many energy collectors. As to beaming power, recent experiments at Caltech have for the first time achieved this by building a system that generates microwaves and beams them very specifically to a point on Earth. The amount was very tiny, just 100 milliwatts of energy, but they did indeed receive the power on the ground. though in a much weakened state. For a viable system, producing about 100 megawatts, eventually a structure could be built that would be about 1 square kilometer in size to collect solar energy for beaming back to Earth. But that it can be done at all has now been shown. These are the very first baby steps of eventually building a Dyson swarm. Number 6. The Scarred White Dwarf. A white dwarf is essentially the cooling ashes of a former normal star. Indeed, a white dwarf ending is what's in store for the Sun. It will basically cool in this state for 10 billion years or so, until it loses enough heat to be a cinder, or black dwarf. Not a huge amount happens during this phase, but a newly discovered white dwarf shows how dynamic they actually can be. Known as WD 0816-310, this newly studied white dwarf shows what really can be only described as a giant metallic blemish on its surface. The star is in a class of white dwarf known as polluted white dwarfs, where metals are found, but they typically are distributed evenly across the white dwarf. This is thought to be the remnants of planets that have fallen into the white dwarfs, and that's probably what this blemish is, but it's not evenly distributed. It seems clear that whatever is causing the material is being funneled into this spot by the white dwarf's magnetic field. Here, a small planet, probably a large asteroid actually, was relatively recently devoured. Oddly, this sort of spray of torn-apart asteroid might give us further clues on the composition of that asteroid in another star system entirely before it was destroyed. Number 5. Making glass fiber on Mars. Mars is often cited as a harsh place. The book and subsequent movie The Martian depicted the protagonist using the Martian soil to grow food and eke out survival. This was later a problem discovered, however, when the Martian soil was found to contain perchlorate, which is a problem for a growing medium, though the soil can be washed to remove it. Now there may be a better option, and it may be multi-use. Researchers in China took recreated Martian soil and heated it to see if it could be made into fibers, much like what was done on Earth with glass fiber. It turns out the Martian soil can make good fiber, and if used structurally, matches steel, allowing for a much more efficient way to create strong structures on Mars than transporting steel there, or collecting up iron meteorites, or setting up mining facilities. But this fiber can also be used as a growing medium on Mars, because it actually holds water better than the unadulterated Martian soil does, and you can even make clothing with it. I'd say a t-shirt made from Mars would sell well if exported back to Earth. Number 4. Seaweed as a tool to help mitigate disaster. Natural or human-caused disasters are certainly still possible in the modern age, more so today in certain regards. We are still under threat from catastrophes such as nuclear war or an asteroid impact. It's always been rightly assumed that these are at least near extinction level events, or they are extinction level events. If you release enough material one way or another into the atmosphere of Earth, it's been known for a very long time that large-scale agricultural collapse will follow. Not enough sun, not enough plants. With nuclear winter, it's estimated that agriculture would decline by 90% within 1 year. Global temperatures will drop dramatically, and most importantly, sunlight will be blocked to a large degree. But there are people that think about these things, and recent work has shown that one edible food source that wouldn't be so severely affected is seaweed. Networks of basically ropes attached to buoys could be deployed in certain parts of the Pacific Ocean that could grow up to 15% of the current food supply, along with animal feed and biofuels. That may not sound like much, but it would save a lot of lives from starvation in a world with an already dramatically contracted population. Along with preserved agricultural capabilities in the tropics, which would still have enough warmth and light, such a horrible, horrible prospect such as war or an asteroid impact's effects to some degree might be mitigated in the aftermath. Number 3. A new record for volcanic eruptions. About 7,300 years ago, off the coast of the Japanese island of Kyushu, the largest volcanic eruption of the current Holocene age happened. That we know of anyway. This newly discovered eruption is estimated to have produced over 3 times as much volcanic ash as the largest known historically recorded eruption, which was Mount Tambora in 1815. This eruption was previously known, other than its scale, but ash deposits and archaeological work showed that humans living nearby were dramatically affected. Recent studies by researchers in Japan have shown that this volcano turned 70 cubic kilometers of rock into ash and threw it into the atmosphere. While this blast seems titanic, it's only the largest known one for the Holocene. If you go back further, there is the Toba supervolcano about 74,000 years ago that was orders of magnitude larger, producing 2,500 cubic kilometers of magma. This new find, however, known as the Kikai Akahoya caldera, still has a hot magma chamber beneath it. And while it's thought that the chances for an eruption today are very small, it's not impossible that someday it may become active again. Number 2. Bennu may have originated from an ocean world. In September 2023, the OSIRIS-REx sample return mission brought material from the asteroid Bennu back to Earth. Bennu is an interesting asteroid because it's carbon-rich, not unlike certain meteorites found on Earth that are similarly carbonaceous and have links to life on Earth, often containing amino acids, the building blocks of life. The Bennu samples were wildly successful. The aim was to return about 60 grams of material from the asteroid, but the actual haul turned out to be twice that. Not all of the results are out, but initial findings include that the samples contain clays, and specifically minerals called serpentinites. Here on Earth, these minerals form because of water. Basically, material pushing up from the mantle gets exposed to water, and these minerals are the result of the resultant chemical action and the heat that it generates. Weirdly, the samples also contain phosphates rich in calcium and magnesium that are actually also seen in the plumes of Enceladus. This is all pointing to Bennu having originated in a planetesimal, one of the tiny minor planets that once populated the solar system and now make up the main planets through relentless collisions in the early solar system. The one Bennu originated from may well have been some type of small ocean world, perhaps not unlike Enceladus, but likely much smaller. Also found were oil-like inclusions, called nanoglobules, that resemble something like the beginning of a protocell wall. This is not a candidate for life, however. Rather, it's a sample of what early Earth might have been like, and the rocks falling on it, that is not contaminated by Earth life. Life has changed our planet dramatically, so we don't really have any samples of Earth before life, but Bennu seems to give us clues as to what that was like. Number 1. We may have forced the Moon into a new geologic epoch. The Moon's surface is as geologically unchanging as it gets. It no longer sports the once great volcanic resurfacing events that poured across its surface and created the familiar lunar maria that we see from Earth. Those days are gone, and even smaller volcanic activity has, as far as we know, almost entirely ceased. Most of the action that happens on the Moon these days is the result of the activities of the solar system itself. Meteorite impacts and meteoroid-driven lunar gardening ever so slowly pulverizing the surface. But the Moon may not be so dead anymore. It may have just entered a new geologic phase. And it's our fault. On Earth, human activity is so prevalent and affects the planet so much that we've defined our current age as the Anthropocene. Some researchers suggest we need to do the same with the Moon. The idea is this. We've been landing on the Moon for a very long time, since 1959, when the Soviet Luna 2 mission intentionally impacted the surface. And it's been nothing but more missions since, including Apollo and now NASA's planned return to the Moon. Lunar visitation is hot these days, with multiple countries, now including India and China, now in the game of lunar surface exploration. And Russia is planning a return. Even private companies have entered the market. Make no mistake, humans are returning to the Moon in force. While our footprint, pun intended, on the Moon is still very small, it still locally far exceeds what the solar system's bombardment can do to change the surface of the Moon. To date, we've disturbed the surface over 59 times and counting, and this is not likely to stop. Eventually, things like colonization and mining will disturb vast areas of the moon, and it'll be a question of international agreement to perhaps leave some areas pristine. All of this seems to amount to one thing. The moon is now in its own version of the Anthropocene age. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently advocating that we avoid changing the face of the moon that we see. It would be a shame to change the face of something humanity has gazed upon for our entire existence. The far side, however, game on. I want to put a giant SETI radio telescope there. Be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live. "2024 so far is proving to be a very important year in scientific discoveries all across the board in many fields, more so than usual. So here are 10 recent scientific discoveries for May 2024. Number 10. Inventing zero. The story of the digit zero is a strange one. In ancient mathematics, it crops up repeatedly, but not always in the form we think of it today. Rather, the idea of a value of nothing was common. It was just a question of how to express that. Indeed, the ancient Greeks asked how nothing can be a something. And there is some wisdom to that. But the mathematical usefulness of zero has won out in modern math. It's just too useful as a symbol. But once you know what zero means, there's almost an intuitive understanding of it. But the big question is, how did it come to be that we understand the concept at all, instead of just working only with actual quantities? Researchers working with MEG scans of living brains looked at people thinking about numbers. Interestingly, thinking about numbers up until about 9 shows differing magnetic patterns in the brain. When showing someone 0, the pattern was most similar to that of showing them a 1. The researchers hypothesized that there may actually be an evolutionary reason for this, in that it may be useful to scan your surroundings for predators. And when you conclude that there is nothing there, that may form the basis of understanding zero. Humans have taken this a step further. Many animals seem to understand the concept of nothing is there, but humans have taken it to actual mathematical levels. Oddly enough, other studies have shown that in people suffering strokes, a certain small percentage are left unable to process numbers containing zeros, but have no problem with other numbers, at least supporting the idea that different areas of the brain process different numbers, and that zero may be the hardest, most important, ingrained one. Number 9. The self-purifying water bottle. Purifying water remains an issue in much of the world. Developing countries, remote areas, areas hit by natural disasters, and so on, can have serious problems with providing clean water. Ideally, solving this issue would be to provide a method of purifying water as locally as you can get it. We have that in the form of water purification tablets and other means, but there may be an even easier way to do it. Install purification systems in water bottles. Researchers in South Korea have invented just such a bottle. It actually uses static electricity buildup from human movement. In other words, people carry around the bottle of water, and the static electricity they accumulate is used to power a tiny purification system inside the bottle. It works like this. On the outside of the bottle is a strip of metal foil that serves to channel the static electricity to a polymer electrode inside. The electrode has nanorods on it that concentrate the electric charges coming in and transmit them to the water as an electric field. This field is strong enough to kill all bacteria and viruses contained in river water in only about 10 minutes of continuous movement. What's really promising here, however, is the fact that it's cheap. Each bottle is estimated to cost only about $2 and should be fully reusable many times. Number 8. The origin of the moons of Mars. One of the many mysteries of planet Mars is just how it came to acquire its 2 moons. The predominant hypothesis is that they are captured asteroids, which they do look like. Another hypothesis, however, is that they formed much like Earth's moon and were ejected from impact events. But a new hypothesis adds another option. that they are two fragments of a broken up comet. The team was looking at unpublished data from ESA's Mars Express orbiter specifically regarding Phobos. It turns out that it actually reflects light more like a comet does than an asteroid, meaning that Mars's moons might be chunks of a comet, or were once a binary comet. Those are actually a thing, and a relatively recent discovery. They seem rare, but a captured binary comet would solve some of the mysteries about Mars's moons, in that both of them are orbiting Mars's equator in a way which would be difficult to reproduce with two asteroid captures. Interestingly, we will probably know the answer to this by 2031. Japan's Martian Moons Exploration mission will return samples of Phobos for study here on Earth. Major abundances of things like carbon, oxygen, and nitrogen would reveal whether Phobos was once indeed a comet. Number 7. Ancient brains. You'd think the skeletal remains of a human from centuries ago or more wouldn't contain much or any soft tissue. You certainly wouldn't expect a brain. But the brain actually is one organ that has a tendency to preserve above almost all other soft tissues. A recent study of over 1,300 cases of preserved brains as old as 12,000 years old showed that it actually happens in a variety of different environments, from shipwrecks to deserts. And it's unclear why, since the brain would seem to be an easily decomposable mass of mostly cholesterol. But they do. Many cases of preserved brains are readily explainable. Inca mummification burials basically freeze-dried the brains in the cold, arid conditions. Bog people in Europe were tanned, much like leather, and of course the tendency for fatty substances to saponify, basically turn to soap in the grave if the conditions are right, but not in these 1,300 cases. So the usual suspects as far as preservation tend to preserve more than just the brain, but many other soft tissues. With these, they were bare skeletons with brains. And this effect has been known for a very long time. There are saints that have been exhumed and found in skeletal form, but with brains, that were in days past ascribed to divine intervention, kind of partial incorruption. But the answer is probably something chemical. According to the researchers, some reaction between iron and lipids and proteins post-mortem might favor preservation of this nature, especially when protected by the cranium. Interestingly, the brain material, if not in an intact skull, looks a lot like soil, leading to the suggestion that forensic archaeologists may be missing an important clue in what they were trying to figure out. Number 6. A new impact crater candidate identified on Earth. While locally known since time immemorial, a feature in India's state of Gujarat had in the 20th century been suspected of being an impact crater, but for some reason was mostly forgotten in the scientific community and not well followed up until recently. Work done by researchers at the University of Kerala have found evidence that it is indeed from an impact through geological evidence, and also what may turn out to be meteorite fragments and local traces of iridium that all point to an iron meteorite having formed the crater. More work on the geology of the crater should prove it, but craters on Earth are nothing new. But this one is particularly interesting because it appears to be recent, very recent. If this is an impact crater, someone saw this form. The crater's age is in question, but appears to be about 4,000 years old, placing the impact event during the days of the Harappan civilization in the Indus Valley. Anyone living in that area that survived it would have seen something very similar to the detonation of a nuclear weapon. The crater itself is 1.8 kilometers wide, larger than Meteor Crater in Arizona, and when it hit, it would have created a shockwave damaging everything in a radius of at least 5 kilometers, and sparking wildfires that would have extended far further. It's possible that whoever was there witnessed what very well could be the only instance of a crater-forming meteorite strike of this magnitude in all of human history. Number 5. The geoengineering clock is ticking. The West Antarctic ice sheet is unusual in that it does not rest on land. Rather, it actually rests on the seabed. This means that warm water can get beneath it and cause melting. That process is happening, and unfortunately it's accelerating because the process exposes a larger area of ice as it progresses. This is bad news because if the glacier continues to collapse, it will reach a tipping point that it can't return from. That's going to see a very pronounced rise in sea levels as it unfolds, as much as a 3-meter rise in already rising seas. Once it hits the tipping point, it's inevitable. The problem is we appear to be very close to that tipping point. There are two estimates, one suggesting that it will happen within 25 years, the other is that the tipping point is around 2030, just 6 years from now. But all is not lost. There actually is a way to halt the process if we act in time. This would involve spraying aerosols into the atmosphere to slightly raise Earth's albedo and reflect more sunlight to compensate for rising temperatures. In principle, this can actually be done employing slightly increased cloud cover using ships that vaporize seawater, or simply adding sulfate into the circulating atmosphere around the edge of Antarctica to reflect light away locally. But it has to be done rapidly or it simply won't work. In other words, within the next few years, it must start. Trouble is, whenever you do something like this, there are unknowns. What happens when you geoengineer the atmosphere to mitigate an unintended geoengineering with emissions? What happens to the weather when you add 1% more cloud cover or reflective materials into the winds? All are wild cards, but any way you cut it, we have a problem with the West Antarctic ice sheet that's going to need to be addressed no matter what we do. Even if we do nothing, the seas will rise. Number 4. The neutrino detecting trees. Detecting neutrinos is notoriously difficult because they only ever rarely interact with anything. One particularly difficult one to study is the tau neutrino, and there are proposals to build detectors to further study these, particularly from astrophysical sources. But astroparticle physicist Stephen Prohira at the University of Kansas, Lawrence, proposed a novel approach that might make constructing such a detector cheaper than building it from scratch. Use living trees to study neutrinos. The idea is that any tau neutrino detector we might build is likely to require a large array of antennas, as one of the products they're searching for, indicative of astrophysical tau neutrinos interacting, are radio waves. Oddly, these detectors look something like a forest, so Prohira thought, why not just use trees? Trees can actually act as radio antennas, they will absorb it, but not very efficiently, so they would need to be wrapped in wire to efficiently function. You'd have to adjust the wiring as the tree grows, but in principle, it should work, though there are questions about very high frequencies that a fully artificial antenna array would pick up, and the trees may not. Number 3. An interesting Mayan discovery. For all its architectural and cultural grandeur, the ancient Mayan civilization seems to have seen a lot of upheaval, both between city-state warfare and also within the leadership of individual cities. A 1,200-year-old site known as Ucanal in Guatemala yielded an unusual discovery that can have a number of interpretations, but all of them are rather disturbing because they amount to some kind of desecration of a grave. Researchers from the University of Montreal were excavating beneath a pyramid structure when they uncovered a group of bones from at least 4 different people, along with bits and pieces of their funerary goods, and they showed evidence of having been burned at high temperature. The funerary goods included parts of a burial mask that would have only been used for a royal tomb, and the careless nature in which the burned bones were buried shows not a lot of care was taken, as normally would have been for a royal burial. But this did not happen in life. These remains were burned after they were buried. One particular individual was shown through radiocarbon dating to have been dead at least a century before the burning of the remains, which happened between 773 and 881 AD. Interestingly, this correlates with evidence of the rise of a certain leader at Ucanal named Papmelil, who seems to have gained power as an outsider of the then-established regime in the city, at a time of unrest throughout the Mayan civilization at large. Researchers think that the burning may have been a ritual, symbolizing the destruction of the previous dynasty and the birth of the new one. I'm a bit skeptical of this, however. This sort of thing is not the first time royal graves were desecrated in human civilization. It's almost always done as a denunciation of that ruler or a group of rulers. I'll cite 2 examples from different parts of the world. The first is the emptying and desecration of the French royal tombs at Saint-Denis Basilica, which were opened and then unceremoniously dumped in a mass grave outside the church during the French Revolution. And to this day, though reinterred in the basilica's crypt, most of the remains of the French monarchs are a jumble of bones mixed together. The other was the tomb of the Wanli Emperor in China who died in 1620. His intact tomb was opened by archaeologists and his skeletal remains were found. But a few years later, during the Chinese Cultural Revolution, the bones were taken out of the tomb, denounced, and burned, and what was left thrown out. None of this was ceremonial. So to pin the Mayan case on ceremony rather than just old-fashioned desecration, politics, and anger would probably need a few more similar finds to be convincing. Number 2. Atoms observed acting as waves. The quantum physical world is weird. When you get into the subatomic, particles act counterintuitively to our day-to-day existence. They pop in and out of existence, quantum tunnel, get entangled in many other things that our world does not do. But the world of the large is still quantum. It's just that the effects are getting lost in the complexity and the mix of the world of the big. This line is usually put at the atom, but individual atoms can exhibit quantum effects under the right conditions. One of these is acting like a wave, in this case a type known as a wave packet. Worth noting here is that the behavior of a wave packet was predicted by Erwin Schrödinger many years ago. Researchers in France recently took atoms of lithium and cooled them to near absolute zero in a vacuum, and then used lasers and magnetic fields to slow them further and arrange the atoms so as not to be too close, and confined them in a wave packet state. Then they let them go. Schrödinger had predicted that if you did that, the wave packet that could freely move would expand as time went on as part of its wave behavior. It starts as a dot and becomes fuzzy and wider. And that's what happened in the experiment. They literally saw atoms behaving as waves, exactly as had been predicted. This is a wide open area of science right now because it's very difficult to predict what sorts of quantum states of matter might be possible in all of this, or what that might be useful for. Number 1. The Wigner Crystal. This entry represents one of those times in reporting a science story that I literally get goosebumps. If you really think about what's going on with this one, you may well get that effect as well. In 1934, Eugene Wigner hypothesized that electrons could do something very strange under the right conditions. Known as a Wigner crystal, this hypothesized arrangement works like this. At room temperature, moving electrons can have enough kinetic energy to overcome the force that causes particles of like charge to repel each other. Wigner hypothesized, however, that at very low temperatures, that force would dominate, causing the electrons to arrange themselves into a crystalline lattice. This is exotic matter, and it's made entirely of electrons instead of full atoms. Sometimes known as electron ice, this material has been subject to numerous papers reporting that it had been created, but in every case there was a degree of uncertainty as to if that's really what resulted. In recent years, this moved closer to being proven, with increasingly convincing studies coming out, but it appears that the question has now been answered. Yes, Wigner crystals do exist, and not only that, one has now been photographed. This work done by a team at Princeton actually hadn't expected to actually get a photograph of a Wigner crystal with a scanning tunneling microscope. What they did was essentially sandwich the electrons between two sheets of graphene, only one atom thick, drop the temperature to near absolute zero, and then hit it all with a strong magnetic field. This was tricky because there could be no imperfections. The materials had to be perfect, or the graphene would have interfered, a problem with previous experimental attempts at creating this material. The team was just hoping to confirm the structure of the Wigner crystal, but the microscope uses quantum tunneling as a technique. So as a metallic needle scanned across the surface of the graphene, whenever it hit an electron, it would tunnel, causing a tiny electric current, allowing them to construct it into an image. Sure enough, it was a Wigner crystal, showing the exact repeating triangular arrangement that Wigner had predicted. When they applied voltage to it, the crystal melted into an exotic electron fluid, and a fluid that inexplicably formed itself into stripes. This experiment went into very exotic territory indeed. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently in a celebratory mood. When I first started this channel back in 2016, I didn't expect it to take off, and when it did, I wondered, would I have enough to talk about to make, 30 videos if people like them? This video is number 530 and Event Horizon is at 348, and I still haven't said everything. Anna and the Possum always said I wasn't succinct enough. I say no, and the LeBaron agrees. And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live. The march of scientific discovery continues, and once again, there is no shortage of new information for this month. So here are 10 interesting scientific discoveries for October of 2023. Number 10. The star with two faces. Stars tend to be pretty homogeneous things, showing spectra that show an overall composition that doesn't really change much depending on what side of the star you're seeing. But a recent discovery has shown that at least for a white dwarf, this doesn't have to be the case. Nicknamed Janus after the Roman god that sported two faces, researchers at the Zwicky Transient Facility in California found that the star was very strangely differentiated. One side of the star is composed of hydrogen and the other side of helium. Located 1,300 light years away, it actually fits in a model of white dwarfs where they can transition between hydrogen and helium. And this one was caught in the act. This involves magnetic fields, and it may be that in the case of the star, the field is lopsided, causing the differentiation. This would mess with the star's convection unevenly and produce the effect, though aspects of this are still very much unclear. Weirdly, you would actually see this visually if you were in the star system, as the two halves of the star would show a brightness difference of about 15%. Though overall the star would be much brighter than the sun anyway, due to its maintaining a higher temperature. A very odd star indeed. Number 9. Predicting earthquakes with the GPS system. Predicting earthquakes has been notoriously difficult. There was a time when it was thought that it would be very unlikely for us to ever be able to predict earthquakes. They are chaotic, and you never know when they're going to occur. And you can just know that certain areas are prone to earthquakes, and the longer the wait, the more chance an earthquake will occur. But in recent decades, there have been hints that there might be precursor events to earthquakes that might offer some hope of being able to predict them ahead of time. And we may now be able to do this thanks to the GPS system. We're going to need a much more sensitive system than what we have now to do it, on the order of 100 times more sensitive. But recent studies have shown that gradual but accelerating slips in land movement can be detected by the GPS system and may give up to 2 hours of warning that an earthquake is about to occur. The problem is that they used a huge overall data set, and the resolution is not yet there to do it for individual earthquakes. But as technology advances, it may end up being possible to predict at least some earthquakes and give those living in the areas some advanced warning. Number 8. Weird radioactivity on the moon. We know and see clear evidence of the moon's wild past volcanism all over the moon. You can see what once were great lava fields just by looking at the moon at night. Equally interesting, but until recently invisible to us, was the far side of the moon and the features it presents due to tidal locking with Earth. The far side has proven as interesting and enigmatic as the side we see, and it too sported volcanism, but in a different way and to a different degree generally than the familiar side. In this case, there is evidence of an area known as Compton, Belokovich on the far side that exhibits strange topography, but also elevated levels of radioactive thorium. Taken from the data of China's Chang'e 1 and 2 orbiters has shown that in this area it is unusually warm for the surface of the moon, explained by the decay of thorium and uranium. The only way to get this is past volcanism welling up these heavy metals from deep below the surface. But what we see is only a very tiny part of this upwelling. Deep below is a column of former lava that's solidified and is rich in these radioactive elements inside of a matrix of a type of granite called a batholith, making for one of the most active former volcanic areas on the moon being located on the far side, and is quietly warming it with radioactive heat. Number 7. Nerve clusters and consciousness. One of the great mysteries of the brain and indeed the universe is the phenomenon of consciousness. We still don't know how it emerges, but we do know that we can go to sleep, and we can also get knocked out, and also suffer injuries to the brain that impede it, however it works. But we do know that consciousness does seem to have two components, distinct but integral to each other: awareness and being awake. Researchers at Harvard have recently mapped out clusters of nerve cells located in areas of the brains in animals and human cadavers that found that they do connect, starting in near the brainstem in clusters previously associated with wakefulness, and how they connect with clusters in the central brain, and then to clusters in the outer brain, which is associated with awareness. Using a sample of living humans to further the research, they were able to show how electrical signals travel from all of these clusters and interact. This may give clues as to what consciousness really is, though it's still early in the game. But what it might do in the near term is help doctors better understand a variety of psychiatric conditions, neurological diseases, and even coma after surgery or injury. Number 6. Flies apparently like to play. Fruit flies are not a lot of people's particularly favorite insect, especially if they get into a house. But at the same time, they are very interesting creatures in their own right. But what's always been unclear about the insect world is what sort of behaviors they share with the rest of complex life on Earth. And trust me, the insects are well represented on the complex side of things. One interesting question is play. We see playful activity in a huge variety of life on this planet. It's easy to see in dogs, cats, gorillas, and a host of mammals engaging in forms of play. We certainly do. From infancy to just tinkering with something frivolous like a Rubik's Cube, which are the bane of my existence, I can never solve them, to playing a good game on a computer or gaming console, which incidentally my current game is a playthrough of the Callisto Protocol, which is alright, but not so great on the hard science. But the big question floating around was, do the insects also play? It turns out yes. Research into bumblebees showed evidence that they will play with wooden spheres that they can roll around. One wonders how widespread this is. Do the spiders play? But right now it's the fruit flies, and they like to take rides on spinning carousels. Researchers at the University of Leipzig in Germany did a series of experiments involving food and moving and non-moving carousels. The flies that landed on spinning carousels spent significantly more time sitting on it while it spun than the ones that landed on a stationary carousel. You'd think that if it was unpleasant to sit on a spinning carousel, the flies would just avoid landing on it altogether. But no, many of them flocked to it and seemed to enjoy it and hang around. But some percentage avoided it. Perhaps motion sickness is also a thing in the insect world. Number 5. Europa is leaking carbon dioxide. There's no question that Europa is one of the most interesting objects in the solar system, a very ancient object dating from the early days of the solar system that seems to have sustained a liquid water ocean beneath its surface of ice for a very long time that might provide an abode for life. But it's still very unclear if it really can. We just don't have enough data to establish if there isn't some fatal aspect of that subsurface ocean that precludes it from having the conditions for life to arise. But the hints that it does are mounting, and one very important one has recently been discovered. In short, Europa's ocean is leaking carbon dioxide into space. This is actually a recent James Webb Space Telescope discovery. Observations have shown that CO2 is leaking into space, especially from a region called Terra Regio, which shows very broken up, chaotic terrain where cracks may lead directly to the ocean below. This is also a relatively young area of Europa's surface, just a few million years, showing that the surface of that moon is interacting recently with the ocean below. But there are so-called areas of chaos terrain which are also showing elevated levels of carbon dioxide, making it less likely that the source was comets instead of the subsurface ocean. But this is not an indicator of life in that ocean. Rather, it's simply an indicator that Europa's ocean likely has lots of carbon in it, which is essential for life. It has the main component for carbon-based biochemistry, but it does tick a box and bolster the cause to look more deeply for life in the waters of that moon. Number 4. Updates on the Dimorphos collision. One of the highlights of the year 2022 was the impact of NASA's DART mission into the asteroid Dimorphos to see if we could deflect it, or in this case, slow the small asteroid's orbit of its larger parent asteroid Didymos. This was a proof of concept, because the basic physics of impacting objects are quite predictive, though there can be anomalies if you don't know every single factor. In this case, it was a success, slowing Dimorphos' orbital period by 33 minutes. Interestingly, this is also a case where citizen science has helped to further our understanding of what happened, and it actually created a mystery. This was undertaken by a high school teacher and students at a school equipped with a 0.7-meter telescope that was able to resolve the two asteroids. The weird thing they found is that after the initial collision, the orbit of Dimorphos has since moved a full minute to 34 minutes. This is rather large, actually. The slowing of the orbit may be due to Dimorphos having been previously tightly locked to Didymus, and our impact upset the apple cart and sent it into an irregular state, which there is some evidence for. What might have happened is that the impact caused the asteroid to start liberating, rocking in short, which our own moon does. But in this case, it may have cascaded and caused Dimorphos to go chaotic and evolve into outright tumbling, which the gravitational forces being upset by this would be responsible for the further minute of slowdown. But a more likely explanation is that huge rocks were kicked up by the impact, and as they fell back, they affected the orbit. More recent research that's being done might better support this, that there was a plateauing shortly after impact that would be consistent with material falling back onto the surface of Dimorphos. This, however, eventually will be better understood and the question probably laid to rest as the ESA Hera mission will arrive at Dimorphos in 2026 to make observations of the aftermath. This will be important though, as this is our first real step at asteroid deflection, which will hopefully make humanity immune from asteroid extinction events from here on out. Number 3. The mysterious helium-3 where it should not be. Helium-3 has been the subject of much discussion over the years because of the potential for lunar mining. The lunar soil contains a fair amount of helium-3, which has been presented as an excellent fuel for fusion energy, though the reality of that is more complicated than is often presented. We can probably use it, yes. The science is there in principle, but actually making that reality first comes up against how we're pursuing fusion technology, but also that helium-3, while it could be mined and returned from the moon, is actually not that abundant. Any mining operation would need to sift through 150 tons of regolith just to get a gram of helium-3. That said, you don't need that much of it returned per year to Earth to power the whole planet, and you definitely could run a lunar colony on it. But we won't be doing that with the earthly supply. Earth does have helium, but not a lot of it. It's a resource we should not be wasting because we will run out. And most of it is helium-4, so helium-3 doesn't really factor in, though the Earth's mantle does contain it, left over from its formation. Helium-3 is really more a matter of objects in space, which is how it's generated. But what you really shouldn't find is helium-3 on Earth that's out of place. Yet it's been known since the 1990s that detectable helium-3 exists in certain strata from the seafloor, and it's long been a mystery as to how it got there. This may now be answered, however, and the answer is a bit spooky. The deposit dates to roughly 33 million years ago. This coincides with the age of two large impact craters on Earth, one in Russia and one in the US. What might have happened here is that both the Earth and the Moon were hit by a shower of projectiles, maybe a broken up asteroid or comet, and the impacts on the Moon stirred up the regolith and its helium-3 and threw it into space. It was large enough to survive entry into the atmosphere of Earth and settled in a layer. Interestingly, this research may be backed up by a lack of iridium. Typically, iridium is one of the things you look for in impacts. The great dinosaur killer Yucatan impact resulted in the famous iridium-rich layer found in Earth's geology. But in this 33 million year old layer, you see the helium-3, but not high iridium. The Moon's surface is low in iridium, which would be consistent with a lunar origin for this helium-3 deposit. Number 2. The very real underwater effects of volcanoes has gotten worse. There's no question that volcanoes are among Earth's greatest destructive forces. Populated areas near volcanoes are always in danger, and they can devastate areas for many years, such as what happened with the outright explosion of Mount St. Helens. Something yours truly witnessed as a little kid from across the Columbia River in Oregon on May 18, 1980. It's not something I could ever forget, and the devastating aftermath on the forests and the lakes surrounding it is evident to this day. Worldwide volcanoes remain a force to be reckoned with in seismic zones, but it's not just the surface of the Earth, but also the ocean floor that sees destruction on a human scale. In 2022, the eruption of the Hunga Ha'apai volcano of Tonga exhibited an enormous underwater volcanic flow of a type that wasn't really known about. Volcanoes can produce pyroclastic flows, enormous fast-moving flows of hot ash and gas moving down mountainsides, destroying everything in their path. These currents are enormously hot and are what baked and destroyed Herculaneum in the eruption of Mount Vesuvius in 79 AD. In this phenomenon is something known as a pyroclastic density current, and this can apparently transfer to the ocean when a volcanic flow of this nature hits it, creating an underwater density current. It was known that this phenomenon could happen, but not on the scale of what Tonga's volcano did, which is currently the largest volcanic eruption of the 21st century. How this was mapped out and discovered was simple. It destroyed and cut hundreds of kilometers of telecommunications lines, and caused massive changes to the seafloor that was exposed to it. In a volcanic event, the ocean does not always protect. Number 1. The Bennu Bonanza. To end this list on a high note is perhaps the most significant story in astronomy so far this year. The sample return mission from the asteroid Bennu has returned safely to Earth. Not only was the mission a success, it was a boon. What happened was the actual canister used to collect the samples was to collect up a sample of 60 grams of material from the surface of Bennu and then seal itself for return to Earth. And it did this successfully. The canister is still sealed and will be very carefully opened in a sterile environment and studied according to pre-planned procedures and experiments. But scientists on the OSIRIS-REx mission got more material than they bargained for. The canister sealed correctly, but outside it, the pipe running into it also collected quite a bit of bonus material. This extra material, being bonus material collected outside of the intended experiment, was available for immediate studies by researchers, and so far it's been found to contain water and carbon, which are required for life, giving more evidence that water and carbon compounds coming from space were integral for abiogenesis on Earth. Some component that became us, or all of it, may have come from out there, and that the bane of life on Earth, the impact event, also was responsible for life happening at all. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently concerned about the playing insects. I had to wonder with that entry, what the flies were like after the carousel stopped. Did they return to just flying around normally, or did they show signs of being dizzy? I'd love to know if there was any erratic flight or anything like that noted, but it wasn't mentioned. Dizzy flies, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live. The far future of the solar system will see drastic changes and events unlike anything we have ever experienced in human history, and it will be to the point that it will be difficult to recognize our home star system when compared to what it is now. Some of these events will be quite spectacular, so here are 10 mind-blowing future solar system events. Number 10. The Planetary Nebula. One of the most beautiful objects we see in the Milky Way is a planetary nebula. The name is a misnomer. These nebulae have nothing directly to do with planets. Rather, they were seen to be planet-like in early telescopes, and the name stuck. Planetary nebulae occur when stars shed their outer layers into space, creating an expanding nebula. This happens at the end of their red giant phase, to stars between 1 and 8 solar masses. Essentially what happens is these red giant stars evaporate their own atmospheres into space, causing a short-lived but beautiful planetary nebula, illuminated by the ultraviolet light from the exposed stellar core lasting about 10,000 years. New modeling suggests that this is what's in store for the Sun at the end of its life, and our planetary nebula, while dim, would be visible not only to the rest of the Milky Way, but to neighboring galaxies such as Andromeda, which by this time will be colliding with the Milky Way. The Sun is at the very lowest limit to be able to produce a visible planetary nebula, but modeling shows that the core will be hot enough to illuminate the nebula. Given this event lies billions of years in the future, that's enough time for other civilizations to develop in the galaxy and nearby galaxies, possibly in an intelligence explosion in the universe that may come as time passes. We will be long gone one way or the other, Earth will at least be a cinder, if not utterly vaporized by the sun's red giant phase, and making up part of the planetary nebula. But it's interesting to imagine some future alien civilization studying the planetary nebulae of the Milky Way, noticing one in particular, but never realizing that there was once a civilization in that star system, full of hopes and dreams, but having gone extinct long ago. Or maybe they're still around, and studying the planetary nebula from some new home, perhaps never realizing that it was where they originated. Number 9. The Rings of Neptune. As it stands today, while Neptune currently does have a faint ring system, it's nothing close to the absolute stunning rings of Saturn. But rings are transient things. Saturn only has about 300 million years left in having them, as they're slowly but surely degrading and falling into the planet. This will leave a time in the solar system where it has no prominently ringed planets, but in the far future it will again, but not at Saturn. Instead, it will be Neptune that forms a spectacular ring system. In about 3.6 billion years, Neptune's largest moon, Triton, will cross the ice giant's Roche limit and probably disintegrate and form an extensive ring system, possibly even more spectacular than that currently at Saturn. Ring systems in the universe can get much more extensive, however. The exoplanet J1407b is known to have a ring system 200 times more extensive than that at Saturn. Imagine what that looks like close up. Number 8. The Age of Oceanic Habitable Moons. Currently, the Sun's habitable zone is relatively close in, and we're inside it. But as the Sun ages and expands into its red giant phase, the habitable zone will move outward. It's unclear just how much the Sun will expand, and that greatly affects the equation of what will end up in the new habitable zone during the process. But it's possible that at least some of the outer solar system's ice shell moons might thaw and host surface oceans suitable for life, if it's not already there deep in the oceans under the ice shells. This opens up the possibility for Europa, Ganymede, and Callisto to thaw, and possibly even Titan and Enceladus at Saturn, depending on how much the Sun expands. If it goes too far, the oceans of the moons of Jupiter will boil away, but perhaps favor the Saturn system. If it goes the other way, then 3 habitable ocean moons could exist at Jupiter. If any of them currently have life, that life may undergo a major change in evolution to favor the new reality of surface oceans. But it won't last forever. As the Sun continues to age out of its red giant phase and become a white dwarf, these oceans will freeze solid and very likely end life on those worlds should it come to exist. Number 7. Human expansion and colonization. Perhaps the greatest potential for change in the solar system lies with our own species and technological development. We hold, in principle, the eventual ability to colonize our star system and even terraform some of the worlds present within it. As a result, should we survive into the far future, we could see a day where the bodies of the solar system are radically altered, and even our supply of asteroids could end up mined out. One could envision, with great difficulty, a terraformed Mars and Venus existing eventually with Earth-like conditions, and megastructure arrangements to keep Venus cool, such as a huge sunshade in space, and Mars with an artificial magnetosphere, plans for which already exist and simply requires, in a nutshell, a small magnetosphere generating spacecraft placed in between the Sun and Mars. For something that sounds so daunting as an artificial planetary magnetosphere, it's actually straightforward and not that difficult and could be done with today's technology. We may even someday be able to change the nature and lifetime of the Sun itself. It is possible to engineer a star through techniques like stellar lifting, and get rid of the pesky helium building up inside the Sun that will drive its demise. Whether we ever do anything like this remains to be seen, but there are hypothetical ways we could dramatically alter the solar system. Number 6. Warm Mars. It's well known that Mars was once a habitable water world, much like Earth, and may have spawned life. Indeed, due to panspermia, it's possible that Mars was the origin of life on Earth that was deposited here by a meteorite. Mars today is far from habitable, though there may be pockets and possibilities for microbes, but the surface seems too harsh for life as we know it. But what isn't commonly known is that Mars could in the far future see a second period of habitability, at least for a time. The idea is that in about 6.5 billion years, as the Sun is entering its red giant phase, Mars will start to receive about the same amount of solar radiation that Earth is getting right now. This may open the way for a period of surface liquid water as the copious amounts of water ice melt on that world. It wouldn't be as extensive as Earth, which by that time will have lost its water, but it's possible for a time that some water might be at the surface. It's also possible, of course, that by that time we will have terraformed Mars and are inhabiting it as a temporary stopgap as Earth is destroyed. But this won't last long. As the Sun continues to swell, Mars will share a similar fate to Earth and be scorched. Any humans left will be forced further out into the outer solar system. Number 5. The changing North Star and the future South Star. Known as precession, Earth's poles point at an area of the sky that over long periods of time moves, tracing out a circle in the sky. But it's not that long of a time, and indeed there have been humans in the past that had a completely different North Star. The current one, Polaris, won't still be the North Star in the future, and while we currently don't have a southern pole star usable in navigation, in the future there will be one. The next northern polar star will be Gamma Cephei around 3100 AD. In the southern hemisphere, navigation used the Southern Cross as a pointer as to where a polar star would be. But due to precession, that will change, and indeed it has. There was a time that the ancient Greeks could actually see the Southern Cross, but no longer. Gamma Chameleontis will become the southern polar star. But stars also move on their own through space, known as proper motion. This will have an interesting effect. The brightest star in the night sky, Sirius, will move into position and become the southern polar star sometime around the year 66,270. Number 4. The last total solar eclipse. We live in a very odd time. Not only is there a civilization and intelligence on this world, but we're also oddly lucky in that we have a moon and sun where their apparent diameters can sometimes be almost identical, allowing for full total solar eclipses on the surface of this world. This is probably unusual for most civilizations, since if the moon were any closer or any further away, the sizes as we see them wouldn't match. You'd either have an oversized eclipse or an undersized or annular eclipse. To see a perfect eclipse is probably a rare thing for any observer in the universe. In the future, however, there will be a time when all solar eclipses visible from Earth will be annular in nature. This is because the moon is very slowly distancing itself from Earth at about 4 centimeters each year. In fact, when the sun goes red giant, the moon's orbit will be something around 40% wider than it currently is. As to when the total solar eclipses will end, the last of them will happen about 600 million years in the future. But by that time, if we're still around, we'll probably have colonized the solar system in space. And if you're in space, then positioning your spacecraft or habitat to experience artificial total solar eclipses would be in the cards. Number 3. Tidal locking and the death of the moon. One thing we commonly hear about small sun-like stars like red dwarfs is that the habitable zone exoplanets orbiting them are probably tidally locked, in that they show only one face towards their star, much like the moon does with Earth. This is the case for the famous TRAPPIST-1 planetary system, where members are so close to their star that they are tidally locked. What's surprising here is that there actually is a chance for Earth to become tidally locked to the Sun. But not yet. The chance comes in about 7.5 billion years during the Sun's red giant expansion. There's a chance that Earth and Mars might become tidally locked to the Sun. This is long after all life on Earth will be gone, and the state of affairs won't last long if Earth is finally swallowed up by the Sun, though it's still unclear whether it will get swallowed or not due to the uncertainties of just how far the Sun will expand. If, however, Earth and the Moon survive the red giant phase, in about 65 billion years, the Moon's orbit will have decayed, and the opposite of its early distancing from Earth, and may actually collide with Earth in a spectacular far future impact. Number 2. The helium flash. The final stages of the Sun's red giant phase are strange and unstable. As its layers expand outward, its core will contract and begin to form a white dwarf. But there is a very sudden and strange effect that's thought to occur, a helium flash. As the Sun reaches its full potential as a red giant, its core will heat up and the pressure will rise under the contraction of the core. This gets so great that at about 100 million degrees, helium begins to fuse and form carbon. The circumstances of the core will make helium fuse much faster than it normally would, causing a somewhat large percentage of the helium core to fuse in only a few minutes. This is the helium flash, and in those few minutes, the Sun's core will be on the level of all of the combined luminosity of all stars in the galaxy. But you wouldn't see it. The conditions of the core will be such that no energy actually escapes, so the red giant would remain unfazed for a time, as the helium flash is the death knell for the red giant phase of the Sun. The aftermath results in core cooling and lower pressure in the shell of fusing hydrogen around the core, causing a catastrophic drop in output. In a relatively short period, perhaps something around 10 millennia, the diameter of the red giant shrinks, as does its luminosity, until it's just a few percent of what it was. The result is a period where the Sun will be an orangish subgiant star, and then eventually a red giant again, but then to the planetary nebula stage, and the evolution of the Sun into a white dwarf. Number 1. The death of planet Earth. Before the Sun reaches its white dwarf phase, it will reach a maximum red giant radius of something around 256 times of what it is today. This is almost certainly the end of Mercury and Venus, though there is a chance for Mercury to get ejected from the solar system entirely in the meantime, or a very small chance it may hit Venus in the carnage of the end of the solar system as we currently know it. Earth and the Moon, however, are a toss-up. It seems most likely that they will be destroyed at this time as well, but that has been debated, and they may simply be scorched and left cinder worlds compared to what they once were. The actual destruction of Earth during this period will be by falling into the Sun. Whether it is destroyed or turned into a molten ball is irrelevant. By this time, almost all traces of this world once hosting life will be gone. The only chance would be interstellar panspermia, if that is indeed possible, spreading Earth life to some passing star system earlier in the history of Earth. Or perhaps it's already happened in one of the many stellar encounters our system has had in the past. Otherwise, a few traces of human civilization may be recognizable through the technology we've sent into space. But even then, at this point in the far future, all traces of that may be gone. If we've colonized other star systems by this point, we too will be survivors, but most evidence of our origin on Earth may be long forgotten or lost. Barring that, in the future of the solar system, it will be as though we never existed at all. Thanks for listening. I am futuristic science fiction author John Michael Godier, currently pondering what a galaxy-spanning YouTube is going to look like in 7.9 billion years. Something tells me there will be cat videos, but different. Instead, it will be Glorkon the Absolutely Gorgeous showing off his pet Slar to the galaxy's collective amusement, especially when it playfully eats a multi-billion-year-old YouTuber science fiction author. Not looking forward to that, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live. The universe is unbelievably enormous, so much so that we can't even see all of it as much as we'd like to. And indeed, we don't even know how big it is beyond what we can see. But the universe, for all its hard rules and absolute physical laws, does allow for some hacks that sometimes let us see things that we normally would not. Few universal hacks are as mind-blowing as the idea of gravitational lensing, where while you might not be able to physically build a telescope to observe extraordinarily distant objects within the observable universe, nature through gravitational lensing can sometimes build one for you, on a scale probably even beyond that of the most advanced civilizations in the universe. So here are 10 mind-blowing gravitational lensing events in space, and indeed, this is a topic we're going to hear much more about in the future, as nature itself, in certain circumstances, provides the most powerful telescope possible. Number 10. The first detected planet in Andromeda. The Andromeda Galaxy is currently just over 2.5 million light-years from us, and it's getting closer. In the far future, the Milky Way will collide with and merge with Andromeda, but that won't start for another 4.5 billion years. Even at such astounding distances, Andromeda is among the closest galaxies that allow for us to study individual stars within it. But planets are a different story at that distance. Only very special conditions, such as gravitational lensing, can allow for situational discoveries of exoplanets. And it's already happened, at least tentatively. The first candidate of an exoplanet within the Andromeda Galaxy is known as PA-99-N2, and through gravitational lensing shows that the system is that of a star with a smaller companion. This companion would have to be an exoplanet, but an enormous one at about 6.34 times the mass of Jupiter. This is significantly smaller than brown dwarf territory, however, which would need to be about 75 times the mass of Jupiter. So this planet would be a kind of supergas giant. So it seems within our grasp to detect more gas giants, at least within Andromeda, with this method. But while we may not be able to detect Earth-like terrestrial exoplanets, there may come a time when we will. When the two galaxies collide in the far future, all of a sudden the exoplanets, billions of them from another galaxy entirely, will become available to us. Here my science fiction author imagination fires. Think the collision wars, where the species of the two galaxies, and perhaps some form of far future humans, confront to determine who controls the merged galaxies. Or it could go the other way, and the species of the two galaxies greet each other and plan for the future of the resulting Milkdromeda galaxy, and the eventual end of the universe as we know it. Number 9. PKS 1413 plus 135. One of the many strange phenomena that the universe displays is the BL-LAC type object, a subtype of blazar. This is an active galactic nucleus with relativistic jets that display really large variations in brightness, setting them apart from other active galactic nuclei such as quasars. One idea about these objects is that they represent relatively low-power elliptical radio galaxies. We just see their jets pointed right at us. The weird thing about these types of galaxies is that they show apparent superluminal motion, or material seemingly traveling faster than light, when it really isn't, and it's just an effect of material traveling at very near the speed of light seen from our vantage point. But there is a type of gravitational lens that might help in the study of such objects, at least at radio frequencies caused by the amplification of light coming from clumps of plasma moving relativistically along the jets, blasting away from the active galactic nucleus's central supermassive black hole. Researchers found this apparent effect with an object known as PKS 1413 plus 135, where the object has dramatically brightened on short time periods several times in the last 20 years. Something with an enormous mass, 10,000 times that of the Sun, is acting as an occasional gravitational lens, causing the amplification of the light from the plasma at the black hole. There are candidates for what this could be. The most likely seems to be another foreground black hole causing the lensing, perhaps even a primordial one from the early days of the universe floating in the intergalactic medium. Number 8. The Quasar and the Rogue Planet Cluster. Sometimes objects in the universe are not just strange for a single reason, but many. The quasar RxJ1131-1231 is one such example. Here we have a really bizarre quasar where it's being powered by a supermassive black hole, but a weird one. This black hole, located about 6 billion light-years away, is emitting X-rays from its accretion disk in a way that indicates that this black hole must be rotating at half the speed of light and must be being fed astonishingly titanic amounts of dust and gas. But even the ability to study and know that required gravitational lensing due to an elliptical galaxy and its gravity in the foreground. In fact, observationally, this quasar appears as 4 images due to the effect. But that's not all that this instance of gravitational lensing has offered. What appears to have been a very large population of unbound rogue planets were observed as a result of the effect. Apparently, a high number of objects ranging in size from that of the Moon to that of Jupiter, not bound to any star, appeared to be present in this relatively distant quasar 6 billion years ago. An entire cloud of rogue planets, as it were. Number 7. The Twin Quasar-Related Planet. In 1996, while we still weren't sure exoplanets outside the solar system even existed, though by that time everyone suspected they did and there were candidates, a very strange event was seen that led to the first ever candidate for an extragalactic exoplanet, even during the very earliest attempts at observation of any exoplanets. The problem is we can't ever confirm it, as it was a transient one-off event. The story goes that a quasar was being observed, and a microlensing event just happened to occur that produced a twin image of a quasar by way of a lensing galaxy. But variation in the observation showed that something else caused some additional lensing. The best hypothesis is that a one-time chance alignment happened where a roughly 3 Earth mass planet happened to move in the field of view and alter the normal profile of the lensing by the foreground galaxy. Now, can't ever prove this one, but if it was an exoplanet, it was an amazing 4 billion light years away, and we saw it. And at 3 Earth masses, that's actually a really small planet to even be able to see, even if it were within our own galaxy. Yet, the magic of microlensing allowed us to glimpse, just once, this very distant world. Number 6. The Einstein Rings. In 1912, Albert Einstein predicted that a gravitational body could bend light, essentially as a kind of lens. This was a foreshock to the publication of general relativity in 1916 that suggested a phenomenon that could in principle be looked for and, again in principle, be tested by observation. The effect was written about in 1924 by Orest Kvolson, who predicted a ring effect between a source, the gravitational lens source, and the observer in a very specific way. That need for a near-perfect alignment made Einstein skeptical that we would ever see such an effect. Indeed, in 1936, he stated that there was no hope of ever observing this phenomenon directly. Here, Einstein was proven wrong. Behold, an Einstein ring. What you see here is a foreground object gravitationally distorting the image, as we see it, of a background galaxy. What should look something like this is distorted gravitationally to look like this. Where Einstein messed up was that he was thinking in terms of stars, and the chance observation of something being gravitationally lensed by a star is low, though you could do that artificially relatively straightforwardly with the right instrument placement. But Einstein wasn't thinking in terms of really huge or gravitationally powerful things like entire galaxies or black holes. There, the chances of lensing events are much greater, and we have many examples of them, though the first complete observation of one didn't happen until the advent of the Hubble Space Telescope. But about a star forming an Einstein ring with another star, while we haven't actually seen that in nature as far as I can find, we actually might in 2028 if the alignment is absolutely perfect, which the chances of that being the case are about 45% from what we currently know. Alpha Centauri A, from our perspective, will pass in front of a distant red star, and we might see Einstein's predicted but highly unlikely event, just 116 years after the prediction. Perhaps they are not as rare as Einstein imagined. Number 5. A planet in the galaxy M51. The galaxy M51, also known as the Whirlpool Galaxy, from our perspective is one of the most amazing and majestic that we can see, even with relatively small telescopes. It's interesting in other respects, one of which is that it appears to be actively forming stars at a high rate, which may be due to a close encounter with another galaxy known as NGC 5195, and the interactions between the two are responsible for the burst of star formation, which has been going on for hundreds of millions of years. And it's a galaxy we've known about for a very long time. Whenever you hear a designation of M, such as M1 or M51 or M31 for Andromeda, that refers to a catalog of essentially fuzzy objects observed through the telescope by French astronomer Charles Messier in the latter half of the 18th century, M51 first being observed by him in 1773. Messier essentially scanned the skies very carefully with his telescope looking for anything that wasn't a star, basically looking for smudges in the sky, and his work was so good his catalog is still used in astronomy today. But what Messier could not have known was that there were planets in the galaxies he was observing, though I think had he known what we know now, he'd have been absolutely amazed. M51 presents the object M51-ULS-1b, which was discovered in 2020. This is an odd one. What's going on here is that there is a high-mass X-ray source, which is very likely either a black hole or neutron star, along with a big, probably Type B supergiant star in a binary system. Something seems to distantly orbit the X-ray source and eclipses it, and the best candidate here is a big planet, but smaller than Saturn, or perhaps comparable to it. That's pretty amazing really if you think about it. We may have a very special situational observation of a somewhat small Saturn-like gas giant in a galaxy over 23 million light years away. Pretty cool, I think Messier would approve. Number 4. Einstein's Cross. This is the quasar Q2237+30, and it illustrates how situational gravitational lensing can be. It's juxtaposed behind the center of a galaxy known as Huckra's lens. This is after scientist John Huckra and colleagues that found this object in 1985. They didn't see this image, however. what they discovered with their instrumentation was that there was redshift weirdness with this object. This was later found to be because the gravitational lensing effect was in just such a juxtaposition to project 4 separate images of the quasar. This particular example exhibits a redshift such that it must be about 8 billion light-years from Earth, while the lensing galaxy must be about 400 million light-years distant, since several other examples of this have been found and represent a very unusual and situational variation of gravitational lensing, on top of the general overall effect. Here I think it would be Einstein himself that might approve, or perhaps disapprove. Number 3. SN 1987A. In 1987, I was already an amateur astronomer at about age 12. I had just seen Saturn through a very small department store telescope my parents had bought me as part of a microscope and small telescope set. And just when I learned what a supernova was, there was one happening very brightly and visible to the naked eye that I couldn't see because I was in the northern hemisphere. Thus I missed the supernova SN 1987A. But the scientists did not, and this was the first supernova in modern times that was relatively close that we could observe in depth. SN 1987A happened in the Large Magellanic Cloud, which is a dwarf companion of the Milky Way, with the supernova being about 168,000 light-years from Earth. We had seen supernovas before. The previous one had been Kepler's supernova in 1604, described by Johannes Kepler himself, and now we know of the supernova remnant from it. But we hadn't ever seen a close one from our perspective in modern science with modern instruments until SN 1987A, and only within the last few years has evidence of the resulting neutron star been found. But in regards to microlensing, something weird happened with this supernova that has never been resolved. When a supernova occurs, the first sign of it is a flux of neutrinos. You see that before the actual flash of light due to the nature of neutrinos in supernovae. In this case, there were 4 instruments studying neutrinos at the time. One specific instrument, the smallest and least capable one, detected a neutrino flux from the supernova 4 hours earlier than the others. This led to the suggestion that a star might have just perfectly passed by, that altered and amplified the neutrino flux for that detector. And even that Earth itself can enhance neutrino intensity at different positions on its surface. Or maybe the supernova released multiple bursts of neutrinos and only one instrument was positioned right to detect the first burst. Until we see more close supernovas, this is likely to remain an obscure but open question regarding supernovae. Number 2. Icarus. In 2018, a star was discovered in the course of studying an extragalactic supernova with the Hubble Space Telescope that didn't seem quite right. A look at previous data showed that this point-like source had brightened significantly over the course of 3 years, and the only explanation is that there was a star in that distant galaxy that was being magnified by gravitational lensing by at least a factor of 2,000 times. But in this case, it had to be a twofold effect. In other words, lensing from a galaxy cluster coupled with microlensing from a smaller 3 solar mass object. There was also a second peak noted in the data that may suggest that Icarus, as it's known, which is thought to be a blue supergiant star, may have a companion in a binary star configuration. What it didn't look like was the usual objects that can be seen at such great distance, in this case about 14 billion light-years away. What it didn't look like was the usual objects that can be seen at such great distance, in this case about 14 billion light-years away, with the apparent exceeding of the age of the universe due to its subsequent expansion. This compounded lensing effect may have been due to a black hole or massive star within the overall galaxy cluster. Studies of stars like this could yield clues about the earliest stars in the universe, this one having emitted its light as we saw it when the universe was only about 30% of its current age. Studies of this might also yield clues on whether primordial black holes created near the birth of the universe could account for a significant fraction of dark matter. Number 1. Arundel. Earlier this year, Icarus was superseded as the most distant seen individual star by a very unusual lensed star known as Arundel, after an Old English term for the morning star, but also a character from Tolkien's Silmarillion. This star is by far the farthest known star, coming in at 28 billion light-years away. Again, this great distance exceeds the age of the universe because of the expansion of the universe since the Big Bang. In reality, however, the light we see left the star about 12.9 billion years ago. Discovered with the Hubble Space Telescope, this star was magnified by about 1,400 times by lensing, created by the galaxy cluster WHL 0137-08. The star is of great interest because the light emitted from it, from our perspective, was just 900 million years after the Big Bang, offering an insight on the very earliest stars in the universe. One thing that can be said about this star is that it no longer exists. What's known is that it was extremely massive, about 50 to 100 solar masses, and would have quickly went supernova, but it hasn't done it yet from our vantage point. So think of it as a kind of time ghost, where we're looking so far back in time that we're seeing something that is no longer there, if you could magically cross the immense distance to it. In fact, there very well may be little evidence of this past star on location, and you have to be at our distance to ever even know it existed. Further study of this star is one of the proposed projects for the James Webb Space Telescope, because being an example of a very early star, it could yield information on whether it's a single star at all, and if there were elements other than hydrogen and helium in its spectra, giving clues to how early populations of stars in the universe began to supply the universe with heavier elements. And it's even possible that this star is so early that it contains almost no elements other than the primordial hydrogen and helium of the Big Bang. Or maybe there will be surprises. But one thing is clear, we're only at the beginning of the study of gravitationally lensed objects. But the study of such objects promises everything from more extragalactic exoplanets to insights on perhaps primordial black holes, dark matter, the earliest stars, and literally represents the universe, giving us a telescope of sorts that can see backwards in time to the early universe. Expect much more from the study of gravitationally lensed objects. And eventually, the very largest human-made telescopes of the future may use the effect in relation to the Earth or the Sun to dramatically increase the power of our observations of the cosmos. Thanks indeed, nature. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently musing about how we give special names like Icarus and Arundel to very far away stars, but typically only unwieldy catalog numbers for interesting close ones. They need to unleash me on naming astronomical objects. Picture it. The beautiful Lebaran Nebula, the McGrib Elliptical Galaxy, the Sriracha Supernova Remnant, and the Mustard Cluster. Won't get far, the IAU never lacks my ideas, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.